forces to the Earth and to the other bodies. And Lagrange point is where that net force is 0 within that frame. So if you put an object there orbiting the sun, it would orbit the sun together with the Earth. So relative to the Earth, that point is going to be fixed. And position of a geostationary satellite, it matches exactly that.
Well, okay, so the reason why I don't think...
Yeah, cool story, bro. I mean, I have ballers just going back and forth in their nonsense. Cool story, bro, but how do you actually send a rocket there? This is what Tanks is getting at. If the rocket...
It's not what anyone's getting at, dude.
Hang on. If the rocket has to leave the Earth's atmosphere at Mach 33 and goes in a straight line according to the laws of Newton, at what point where you're going to send it, does it suddenly orbit, I guess?
It doesn't suddenly go there.
30 miles per hour. Go ahead.
It doesn't go in a straight line.
No
satellite.
Yeah, go. No, I was just going to respond to Bacon real quickly, just about Lagrange. So the way I understand Lagrange, it's about two bodies. It's about a gravitational point between two bodies. So the Earth and the Moon, or the Earth and the Sun, or something like that, where there's like a sweet spot between the gravitational pull of both those bodies. And so I don't think
plus,
that... go ahead.
Sorry. I was just saying plus centrifugal forces, because you're using a rotating frame there, right?
Okay, sure, yeah, because they have to do with orbits, yeah, so that's true. But I just don't think that, well, I'm not sure that a geostationary orbit or anything like that has anything to do with a Lagrange point.
Yeah, it doesn't.
Well, I mean, how you determine where Lagrange point is?
Just to be honest with you, I don't know how it's calculated, but I would think.
Each other up all night.
Yes, as far as I understand,
you're tripping each other up all night.
You get an orbiting frame, you get a rotating frame that represents like the Earth going around the Sun, for example. You use that frame of reference, and then you add all the forces. You add gravity plus the other pseudo force, like the centrifugal force, plus the acceleration towards the Earth at any point. And at some point within that frame, you're going to get a net zero acceleration, right? If you place something there, it would be fixed in that rotating frame. You can do the same using Earth as a frame, and that would put this whole circle of where you can put geostationary satellites. That full circle is going to have a net zero force, because the centrifugal force plus the gravitation towards the Earth is going to get a net zero value, right? Like if you do the same math used to find Lagrange points, you're going to find, but using the Earth as a frame instead, you're going to get a position of geostationary satellites as Lagrange points.
Thank you, Bacon. I'm actually with you. I'm probably one of the few people listening who is actually with you in terms of the basics, how you describe it. Mathematical model. What you failed to take into account now is what Jay has mentioned earlier on, which is the hyperbolic nature of space-time. It's
can I answer that already?
Explosion or advancement. So how do you incorporate that when you send a satellite into a Lagrange point? Where do you aim it? The sun is obviously moving around us. Do you
because
let me finish the question.
No, you guys are interrupting Pete this time. All he did was compliment and then didn't even get to his point.
Yeah, let me finish my question. Where do you aim the satellite at? The sun is obviously moving around. So where do you aim the satellite at to get to a point? Osho, stop annoying me. Go ahead now.
You're not sending a satellite in a straight line. You first make an orbit around the Earth, and then you extend the orbit to either a launch point where you then stop, or to a geostationary orbit where you have to make the orbit a certain way so that the satellite moves the same angular speed as the ground below it. You're not just sending in a straight line and magically it orbits.
Orbits are straight lines.
One second.
Let me just have three ballers coming in with their imagination.
Please.
Peter, you're fucking this whole thing up for a second. Just hold up for a second, man.
I'll just give a concession to Kushu and French Cat, because the definition says here that Lagrange points are relative to two bodies, so what I said wouldn't be considered Lagrange point. So yeah, that was.
I was following what you were saying though, and I was actually considering it. So
it's wrong. I mean, it doesn't fit the definition at least. I mean, it's kind of the same idea, but doesn't fit the definition of Lagrange point. So that wouldn't be considered.
That assumes that the sun is the flat universe, and J. Ace already came in and confounded you. You couldn't answer. I was following him, but we're not dealing in a flat universe because we're in a real 4D space-time continuum reality where everything is not flat.
That's
so
not
how
a
do you
problem.
incorporate then how you're going to send it to Lagrange point in that setting?
Well,
I have the answer.
yeah, that's no. Let me simplify because we don't have to worry about that. Lagrange points exist in Newtonian mechanics. You don't have to invoke curved spacetime or none of that to talk about Lagrange points. We can just talk about Lagrange points within Newtonian mechanics, and that's fine because they exist there as well.
Yeah, Pete. It's because the Earth's gravitational field is what's called the weak field limit, or it's within the weak field limit, which means if you wanted to, you can start with general relativity with this hyperbolic space, and you can use the metric for the Earth, but the final equation you'll get for sending your satellite or whatever, your rocket up, will just be, it'll end up just being the same as Newton's equation with a correction term, but that correction term is always inside the error that you're going to use for this kind of thing. So it really winds up just being the same thing as Newton's equations.
That's not making anything clearer in a sense when it comes to practicality. I understand the mathematics behind it. It's an ideal representation with all considerations taken on board, JAs. But where the fuck do me and you, we're after accelerating time, we're after building a satellite. We want to send it to a Lagrange point, which is at 1 million miles away. Larry Schubel, as you know Schubel well, he told me that is the furthest extent that they've sent a satellite to. So we're going to send it there. It has to get beyond the Earth's atmosphere, 33 times the speed of sound, 25,000 miles an hour, whatever. And then it goes in a straight line according to Newtonian mechanics. What are we going to do? Where are we going to point it towards? What are we going to do when it gets to where it's going to? How are we going to trust it?
I think French Cat was trying to tell you about that you have to send, it doesn't go in just a straight line and then starts orbiting. Usually they take that like curved path that you see rockets taking where it looks like they're coming back down. So they start to go, they have to get the angular velocity.
Yeah.
Yeah, you're making a lower orbit and then
like you swing a slingshot around your head to fire the stone off. They're gathering speed as they go around the Earth, but ultimately to go in a straight line, right?
So at that Lagrange point where the satellite's in perpetual free fall, why doesn't it turn into a sphere like a raindrop?
Because it doesn't have enough mass for the gravitational strength to overcome.
It's in its own universe at that moment. What do you mean? It's in its own little universe at that moment.
No, it's a material that the satellite is made from. And this material will have a gravitational effect on the other parts of the satellite, but doesn't have enough mass for it to collapse into a sphere.
That's all the mass that's within that.
Yes, but that's not enough mass.
System. It's all the mass that is in that system.
And that doesn't really matter because the gravitational field that this mass is generating is not enough to overcome the strength of the materials that the satellite is made from.
Awfully convenient. You can be out there proving
it is awfully convenient. That's right.
It has to be.
No, Deimos, which is like moon of the Mars, which is the size of a city, doesn't have enough mass to turn into a sphere. So why would you expect a few meters satellite to turn into a sphere?
It's just comparative mass. That's just comparative. You're saying that things don't work in the reality that you describe.
Right.
Consider this. Consider this: the tensile strength and like the structural strength of a scaffold or something like that. It's like a crystal or whatever you want to imagine. It's going to have a strength. It takes strength to crush that. Like you have to apply the amount of strength that is going to overcome that structure. And so when you're talking about things collapsing, the gravitational strength, the gravitational force has to be greater than the structural strength of whatever that is in order for that to happen. Which for most things it takes a lot, right?
Yeah, like let's take steel. I know. Let's say that you need 200 newtons to bend steel. I'm probably wrong, but yeah. Then you need enough gravitational strength it needs to be over 200 newtons to even bend steel. And we're not even talking about making it a sphere.
Okay, let's get back on track here. Can we have a one ball earther and one flat earther responding? Because the problem is you have a whole model and you tell me that the walls of the ISS are very thin. It's counterintuitive to myself and tanks, and I think everyone else who actually experiences life and pressure on Earth would think, but yet you justify it via your model, which is fair enough because it's your model and it's your unexperience, I would say, by the way, tactical French cat. You've never experienced any of these things unless you can correct me, and please feel free to interrupt me if you can correct me on you experience any single one of the bowler's basic pivotal foundational principles. But yeah, you've never experienced. So yeah, it's not that your model is incorrect. It's is there an alternative model, and also how does it fare against our experiential reality? That's all. That's the basic consideration.
We have the model, so it's your position to make the other model.
No, make that satellite into a ball when there's no forces acting on it. All there is in there is space, time, or gravity. Turn it into a ball, just like you did the rocks, right? In outer space, somehow they turn into balls. Turn a satellite, not very strong material. Turn it into a sphere at a Lagrange
I know
point.
you like to
I challenge
troll
you.
very much, but even if you made it out of cardboard doesn't have enough mass to bend in on itself. You need a lot of mass, which is a big size. Then we have a huge satellite for just I don't know what even purpose.
Yeah, but you're saying mass attracting mass. I mean, that's what I'm asking. Which gravity you got going on in
Look,
space?
the force of gravitation is very weak, so you need a lot of mass to generate lots of force.
Dude, that little free fall bubble that it's in, that's a massive amount of mass within that little bubble, that satellite.
No, that's a very low amount
End
of
to
mass.
end. It's like, man, that mass takes up the whole thing.
Loads of momentum. It has loads of
You know
momentum,
things.
right? Practical.
If that happened, if NASA like posted a satellite that collapsed into a sphere due to its own
Fucking
weight,
right.
that would debunk NASA. Like that would not look good. Everyone would notice right away that
But we
didn't
shouldn't
match
even,
the laws of
we
physics.
shouldn't even be able
I
to
mean,
leave
but that's
Earth. We should be crushing the balls instantly. No, I'm just kidding. Go ahead.
yeah. I mean that is not something you should expect given the laws of physics that we use. That it's just not the right prediction.
Hang
The
on,
truth is,
hang on, Bacon. What's the distinction between mass and momentum? Do you know you're familiar with
just
Heisenberg's
come on,
principle, right?
Pete.
Yeah, but hang on.
Heisenberg's
No,
principle.
hang on. Let's get places
Peter, come
here.
on, dude. Peter,
Osho,
just
I know your game
chill
here.
out.
I'm asking tactical French cat a question. If you're not
You
capable
just
of
asked Bacon the
answering,
question.
Yeah, you asked the Bacon the
why
question. Now you're saying you asked me the question. Ben, stop being so
Let
confusing.
Kosho, let us hear what Kosho had to say because he started right
But,
with you, and I think he was waiting. Yeah, go ahead.
I don't remember what the thing was, man. I mean, honestly, it was No Tank said something about the I mean, I already said that
Better
about the
remember.
structural strength and all that. Yeah, I don't remember now, man, because pizza was so strange.
Yeah.
You're up, Pete.
Heisenberg's principle.
Well, I mean, I thought he brought up a decent point about the acceleration, right? Mass.
Yeah, he said what's easy. Yeah, yes. What's the difference between mass and momentum?
Well, momentum is a part of, like, mass is part of momentum. Momentum is just, I mean, there's a different.
Mass.
Sorry.
Mass times velocity.
Mass is mass, and mass with momentum makes how's it called? Kinetic force.
Mass with
So-
velocity makes momentum. Kinetic force.
Oh yeah. I confuse the words. In Polish, those are the same.
Oh, all right. Yeah, what is a bit hard to understand the difference is momentum and kinetic energy. Those sound like they're the same, but they're not.
it's a clear problem. We're asked to imagine why the ISS doesn't to collapse into a ball by tanks, right, due to gravity. Well, mass gravity, you're saying that it has to be more mass body, but if a light mass, is traveling at the speed of light, a needle is traveling at the speed of light, it could destroy the Earth or a big part of it. So there's no sort of distinguishing it in equatable terms, anyway. That's
I
what I
don't think
think.
if we have any
This-
craft that moves at the speed of light. And
Go ahead, sir. This is what I was going to say to no tanks. You reminded me, Pete, so I appreciate that. What I was going to say no tanks is that all these things are calculable, meaning that if you have a mass and you travel it at a certain speed, you can determine the momentum and the kinetic force of impact. This is true. And if you know the mass of an object, and the size of it, whatever, you can determine the gravitational force that's acting on itself, that it's acting on itself with, right? And so all you have to do is determine that and see how that relates to its structural strength. It just turns out that most of the time, the structural strength of things are going to outdo, gravitational force of itself. Until you
many
get to a
orders
certain
of
size.
magnitude.
Yeah, exactly. By a long shot. There's, you can determine how big an object needs to be before that becomes not true, right?
You forget I talked to rocket scientists, and he claims to be a man who actually deals in the mathematics. He said he's been through the whole process of sending satellites into space. So you forget, I'm familiar with this argument. So I'm just asking questions, just trying to clarify. If something doesn't make sense, we have to call it and say, well, as a collective, it doesn't make sense. That's all. It might be not true, but
there are certain moons on like one of Mars's moons and a bunch of Jupiter's and Saturn's moons that aren't even spherical. And there's a bunch of asteroids in the asteroid belt, a couple of them actually, that aren't spherical. Most smaller asteroids are not spherical. And this is because they're inside of that size, where their structural strength is actually overcoming the gravitational pull of it, itself, right?
You got that
you see
thing.
these
You
with
got
your
the thing at a.
telescope?
You got the thing at a
Yeah.
point where there's no forces acting on it whatsoever. You claim we'll claim like gravity permeates all things. So now it's mass attracting mass. I don't know what everybody agrees on here, but now you got all this mass there with no other forces acting on it, but it's not attracting mass.
No, it's the
That's
gravitational force versus the material strength. So you just have those two. And if you compare those two, it turns out the material strength is much, much bigger than the gravitational force. So it will not collapse into a ball. It doesn't matter that there isn't any other gravitational field.
So what's your reason that I guess what's there permeating the material? If not, what's holding it together then? It's not mass attracting mass.
The material itself is holding it together. It has a certain strength.
Itself. Right. So where's the force?
Electrostatics.
The force is within you.
Electrostatics and electrochemical attractions and relationships.
Everything is electrostatic by nature, right?
All right. So then it's just dependent on the material, not gravity.
Different you gotta get the whole
different
thing.
Strength.
All molecular and intermolecular. You gotta give the whole little.
Oh yeah, you're right. Yeah, all the intermolecular, all that shit. Yeah.
Sorry, go ahead, Tactical. I interrupted. I think you were talking.
That's actually where that point is relevant. Is that's exactly right. Like all things are held together with that, and so if that defines the strength holding something together. Same thing with when
right. So no
about,
gravity.
Meteors.
That's what I'm saying. So gravity is not.
No, it's not that there's no gravity. There's an equation. There's an in what do you call that? Inequality. Like we have like this. Yeah, this is greater than this. Like any inequalities. It's like an algebra equation where there's inequality instead of an equal sign, and you have to determine when the gravitational force is actually going to be greater than that intermolecular bonds. And there is a point that's reached. It takes a large amount of mass until that's reached. When it's reached, it becomes apparent.
Well, you kind of determine when they're equal, and then if you put any amount of mass beyond that,
above that.
So how do you find the force? You got the mass, right? You got the mass there. How are you going to math it out? You got the mass there. No other forces are acting on it. What's the gravity there at that Lagrange point? With the math, give me the math that you need. You said there's math there. It exists.
Yeah, there is math that has other Lagrange points, but it's the same thing with like when we talk about like meteors hitting the moon and they make circular craters because they explode on impact. Well, you just have to determine what.
Sorry, go ahead.
No, I'm just saying the reason they explode on impact, the reason they create circular craters is because the impact that they hit the moon with, they have a greater kinetic energy that's greater than the total energy of the intermolecular bonds. So all you have to do is have a velocity or a kinetic energy that's greater than that, and they'll explode on impact, which gives you the circular craters. The same kind of thing with gravity. It's like you have to determine what's the total gravitational force or the total gravitational potential energy or whatever that's greater than the entire intermolecular energy to determine which one's greater. And once you get a value that's greater than that, there you go. Which is why certain sized objects are almost always spherical. The bigger the object, the more spherical it'll be.
Hey, cool story, Kosho. Have you been licking Geo's frogs again?
Gio, you gotta admit that was funny. You're so stupid, Pete. That was funny though.
Shit, you're after making me spit my joint out the window.
Oh, have you ever heard? I mean, I'm sure you guys have heard that idea of a flat Earth that accelerates upwards 9.8 meters per second square, right? So
Yeah.
you can have gravity without gravity, you know. A common response to that is that after like a couple months or something, it would reach the speed of light, and that wouldn't be possible.
Yeah.
I think that's wrong. Like that can't be right.
I can prove to you that's wrong because I asked this to Brian the other night. I said, Brian, if you have an accelerometer and it's reading a positive acceleration, right? It's reading a positive acceleration. You would argue that over some amount of time, it doesn't matter how long, but there will be an amount of time where that accelerometer, whatever it's within, has to be going faster than the speed of light. And he said, yeah, that's true. Yeah. But it's not true because you can have it sitting on the table forever and it will always be reading a positive acceleration.
Yeah.
So,
well, that doesn't sink in necessarily. Like a lot of people can just argue that that accelerometer is simply registering gravity. It's not registering an actual acceleration. No.
registering proper acceleration and not coordinate acceleration. Sure.
I don't know, but even if like it's proper acceleration, I don't know what the difference.
Okay.
What is the difference?
Don't let Kosho beat you up again, Bacon. He already embarrassed you once today.
Yeah.
We're not disagreeing.
Coordinate acceleration is the one we're talking about, the one you're familiar with. Coordinate acceleration is the one that involves something changing coordinates, right? Like so something that would be registered in a coordinate frame. But proper acceleration was introduced with relativity. But all accelerometers, they measure proper acceleration. So, if you're measuring acceleration with an accelerometer, it's measuring proper acceleration. But that's just like I said, that's gravitational. Yeah.
You mean like it measures the acceleration you feel? That's proper acceleration. Is that it?
Well, it'll measure, like I said, the acceleration. Yeah, sure, the one that you feel, but it's specific to general relativity. Like that's the acceleration involved in general relativity.
Right.
But so it's confusing. It's confusing because if you put an accelerometer in a car and accelerate, it's going to measure that. So it measures coordinate acceleration as well. So it's kind of confusing.
Well, thank you for reminding me of my point. Yeah, 1 second, Bacon. Thank you for reminding me of my point, Coach O. Well, 1 second. Bowler, flat earther, remember. Thank you for
It's not
reminding me
gonna
of
be
my
1
point,
second.
which was J. Ace's reference to proper motion. What is the proper motion of the Earth as it's considered within J. Ace's 4D space-time
Good
hyperbolic?
question, Pete. But that's a totally fucking different topic, different use of the word.
It's
Not
not.
related.
It's not.
No,
What is the proper
it is.
motion of the Earth as it's considered?
Proper
Answer
acceleration and the proper motion of a star are two different things.
Oh, we'll get there.
of
We'll
the
get there.
Earth. I'm talking about of the Earth. What is the Earth's proper motion considered to be when you are gauging all of these greater
We
considerations?
don't describe the Earth's proper motion in the same way as we describe a star's proper motion or the proper acceleration. But let's let Bacon respond real quick, man. Bacon's got
Give
nothing.
me a minute. Yeah,
You're right, no tanks. You got him again. That's really Bacon.
I bet it's considered to be still. Isn't that why you're struggling? It's considered to be still because the distances are so exclusive when, with these greater considerations, you're dealing light years or bleams, that the Earth has to be considered to be still. Isn't that correct?
No, dude.
That's
Because
its proper
proper
motion.
acceleration is not related to that. Proper motion of a star is related to not the motion, the rotation in a given night, but the motion involved or in reference to the celestial sphere. So, for instance, two stars in the same constellation, their movement in reference to each other as they're viewed from Earth. This is the proper motion, or more specifically, the speed that it's moving in the Milky Way galaxy, in reference to the Milky Way galaxy, not in reference to, not in reference to the way they're viewed from Earth. So it's just a totally different concept. That's all.
That's fine. I'm with you, Coach O. And don't think I'm not with you. Yes, that's within your own modeling. This is where the standard candle comes into it, and the decision to have certain stars at certain distances away. I sort of understand it, you know what I'm saying? But yeah, when it comes to a standard reference, it has to be all returned back to one thing, which is the Earth. The Earth in motion. And that brings me on to a greater question I was going to ask about the decision to have the Earth in motion. For thousands of years, Pythagoras' beginning, it was suggested that there was a ball, but the ball in motion, that wasn't clarified even up to the day today, or even up to Einstein's time anyway. So yeah, very interesting. How would Pythagoras think about going from a relatively stationary Earth surface to, what do you tell me now, that the Earth surface is in motion, a million miles an hour around the sun, that's falling, or maybe going in a straight line through time or space-time or space or one or the other? I don't think he'd like it too much.
This is why all motion is relative. So when you're talking about the speed in reference to something else, it's not it's not a problem when you're comparing it with the speed in reference to a third thing. So yeah, the speed in reference to the sun of the Earth is a value. I think it's like 600,000 miles per hour or something. 67,000 miles per hour.
Yeah, but you have no problem accepting these, and you have to accept them because they're built on a solid foundation, a purposeful mispronunciation there. But we've all seen these. Listen, we've all seen these sort of perspective gauges. We've seen the Earth in relation to the Sun. We've seen the Sun in relation to the Milky Way, or especially what I'm talking about here. We've seen the Sun in relation to other suns, and it's fucking tiny. You know what I'm saying? The only reason you gauge that is because you've decided on, well, the distances, isn't it? So size, composition almost is dependent on the distances decided.
Is it raining there in Ireland? Raining in Ireland?
It was today, man. I love the rain.
He gets us back.
I got a problem with it.
I'm not saying you're incorrect. I'm saying what you're telling me is a necessary sort of continuation of the basic foundational heliocentric model. It's not wrong or right. It's just a way of looking at it. Okay, can we develop some other thoughts? which is, well, all the stars move in unison because we're on a stationary Earth surface, whatever the greater nature of the Earth is. Maybe now the stars are
Peter,
part of Earth, and they're emanations against an enclosed surround. That's all.
a wise man once told me, and you're that wise man, Pete. You once told me that we should be comparing models to reality and not models against models, right? I agree with that, Pete. And that's all I intend to do is compare the models that we're discussing with reality, and whichever one comports closest to reality is the one that we should abide. Talk most about. And so when you say, well, there's this model and yeah, it works well, but let's think about other models. Well, Pete, shouldn't we compare all these different models to reality and really only focus on the one that closely relates to it or closely represents it? Which is, so it's kind of contradictory what you're insisting on right now.
No, I'm with you all the way, and that's exactly what we should do. So, can you come with me? The very foundational surface that the flat earther rests upon is stationary. Are you with me so far? So now we're forced to develop a model on that basic principle because I think it's something we can all swear by. If someone held a knife to your throat, would you say that you experience the stationary Earth surface throughout the course of your life, or would you say the story you're trying to spin me with?
If somebody had a knife to my throat and they were asking me that question, I would assume they were a flat earther and were crazy. No, not that flat earthers are crazy, but that they were crazy because they had a knife to my throat. And I would just answer whatever I thought they wanted me to say. Okay, so I'd probably say whatever it is I thought that they wanted me to say. I wouldn't,
Can we go back to
Yeah, but they're
Please,
they're truth seekers, Kosho, and if they don't think that you're telling your truth, they're going to kill you. So be
If
careful.
I thought he was from New Jersey, and he was a flat earther from New Jersey, I would tell him whatever the hell he wanted me to say because I knew he was going to cut my throat if I didn't. Okay, but
I'll never find the body.
Did you say New Jersey? New Jersey?
Hey, hold on, let's get back to the topic, man. Let Bacon jump in. Go ahead, Bacon.
Yeah. That time where you got the floor and then I left. We were talking about that thing about upward accelerating Earth.
Proper acceleration,
reaching. Yeah, well, I was kind of struggling to explain to other globers why you can accelerate forever upwards 9.8 meters per second square without reaching the speed of light. And so, correct me if I'm wrong, there's no observer that would see you exceeding the speed of light. What they would see is your time on that flat Earth. The time would slow down more and more. So they would see that flat Earth reaching the speed of light or approaching the speed of light, and slowing down the rate of time for that flat Earth.
Almost stopped,
slowing down
until it stopped, basically, yeah.
Oh yeah, almost freezing, yeah. But for the people on that flat Earth, that would never happen.
That's right, yeah. That makes sense, yeah.
It's just a theory anyway. You can't prove that.
Yeah, we're not arguing about whether or not it's true. We're arguing what the theory says couldn't happen.
Yeah, we're just saying what reality is and what theory. We can theorize all day long. We waste a lot of time doing that.
What do we build our models on, Dave? Right, I think hang on, Bacon. What do we build our models on is the question here. If there's a reality in play and there's maybe 5 or 6 different potential models, it all depends on your foundational starting principle points, right? So that's all. It's not about comparing model against model, because you accept the extraordinary from my point of view, Kosho and Bacon. But yes, it's about comparing all models in their completed form against reality. And
not really.
By saying this, the ball earther has no other model to compare anything to in its completion.
That doesn't matter.
Yeah, go ahead.
Well, it doesn't matter. I mean, you make one measurement. Just if it's a sphere, make a tangent line, which is a horizontal line over curved water, and prove it. If it's a flat Earth, you can make that same horizontal line over water and prove that it's not curving. You don't need to figure out how 5 different theoretical models work exactly. All you got to do is make that measurement. Pretty simple.
I agree. Rule out that model then. But the ball earthers like Bacon and Kosho don't seem to be able to rule out their own model, even though they can't demonstrate any one. Rick, think about it. Any one aspect And no matter how refined you want to take it, because they have it refined to fuck, but any one of them they can't clarify. It's all theoretical. In practical demonstration, that's what Tanks was talking about.
Well, I
appreciate
can't disprove their model either because I've only made one measurement. And so if that area is just a flat piece of water on a sphere, I can't prove them wrong about that, right? But what I can prove wrong is that you can create a horizontal line over water and measure it. Now, why don't more people do that in their area? I mean, it can't all be flat if it's a sphere, right?
That's the problem, isn't it? That's what they rely on, Rakia, is they will say to you, or I would say to you, that when you're talking about distances, 6 miles is nothing, you only have 8 inches of deviation, you're talking over greater considerations, and therefore you're not gauging the overall scale properly. That would be their answer, of course.
It's not a problem for me. The problem is wasting endless hours and days and years on theoretical nonsense on how we think light will work over a flat plane or not. Why not just make the measurement?
I agree.
Hey, listen, Dave, we don't know God's plan for us. You can be sure that all of the interactions that you've had, especially in these antagonistic rooms, discordant rooms, have helped you throughout your own life. Maybe helped you in a game of poker. I'm not, I'm just saying. It just made you smarten up.
I can always tell you how many beers Pete's had, dude. I can always get it down. You tell me if I'm wrong. Yeah, 15.
No, you're definitely wrong. You're way off.
So yeah, what's going on in the stars now? Like, there's a lot of people who are done wasting their time, like just leaving the argument. Ricky is about to do that. Sounds like.
No, I'm not.
But
this argument is in my life forever. I will forever debate it or talk to people that I love. I went to breakfast this morning with a church member, and this is what we talked about. I don't know why you make accusations about me about things you don't know. If you want to know something about me, just ask. Thank you.
I mean, it sounds like he's going through a little bit of an issue right now.
Not really. Not really. I've just realized that over the last 6 years, it's every time I go to try and make a very simple statement on how we can measure something, I've been told you can't make a horizontal line over a sphere, which is wrong because they have a tangent line, which is a horizontal. I've been told that maybe the area that I measured is actually flat on the sphere, which, okay, I can't disprove. I've only measured that one area, so that may be true. But these are the excuses that I've gotten, which is ridiculous. And every time that the conversation gets brought up, I get attacked, or I get the audience gets told what Rocky is doing, when I'm very clearly just pointing out a very simple way to solve this. I'm not going anywhere. You're not getting rid of me, not even you, right? They've tried to attack my family and kids and coworkers and whatever. I haven't gone away in 7 years. What makes you think I'm going away now? That's a dumb thing. I'm just stating the facts.
I don't know who's dumb there, but I mean, but
to be fair,
it's similar to what you're trying to do now. Tell the audience that I'm something that I'm not, which I'm not scared of anything.
That's why I think you're getting. You think it defines you. I don't know why it defines. So you got 6 years in. You haven't convinced anybody. Earlier, I heard you stated that it might.
That's a lie. I've convinced many people.
Oh, that's good then. Okay.
Yeah,
they keep telling. So when you say they keep telling you,
me a lot.
Yeah. So when you say they keep telling, so when you say
about me,
so when you say they keep telling you, what do you mean?
Talking about me?
I'm asking you. You said ask you.
No. Why are you making statements about me?
Yeah, I'm telling you why. Do you want to ask? You want the answer?
Well, I don't know why
you want to keep on talking over me. You want the answer, or you?
Okay, come on, take it.
No, I don't want you to talk about me.
I mean, you don't get what you want, buddy. I mean, that's what you learned in this for 6 years.
So you just come here to talk about other men, which you don't know?
Just Rakia. Just you, bud.
Yeah, just tell the audience what you believe is the facts about Rakia. Why don't you let me tell them? Why don't you ask me a question?
Well, like so when you were talking, you were expressing yourself and like crying on the stand. I mean, were we just supposed to take it in and just be like, okay, Rakia's down and out, and he wants to give up 6 years, and he said he can't make a dent.
I'm not down and out. I never said I was giving up. What? I actually said the opposite. Yeah, I actually said
so when I asked you to clarify, are you giving up, and you said the opposite. That's fine.
Yeah. Now what are you saying?
That was it. I asked you, are you giving up? You said no. You said it's not just a waste of time.
I said that a while ago.
Okay, so it's not a wait. You're not wasting your time then. That's what I'm asking. You're not wasting your time.
No, y'all are wasting your
Okay.
time talking about how light appears. One measurement is what I said. And then you kept talking about Rakia. What you think you know
No,
about
you're
Rakia.
talking about Rakia still. You are. You're still
Yeah, I
doing
know.
it.
I can talk about myself. I can tell you
Only you?
how I feel. See, you can't
Oh, okay.
tell people how I feel. I can tell
I
them
can
that.
tell people how I interpret what you're saying because you're out here speaking,
Yeah, you
asking to
can
be
talk
heard.
about
Yeah.
other men. Yeah,
I
sure.
don't
It
think you
makes
know. I
you
don't
look
think
like
you
a
know
fool.
how it works. Like when you're up here crying
I
like
know
a little
how it works.
girl,
I'm
people
not
are going to
crying about
comment on it.
anything.
That's all. When you're
I'm
up here
not crying.
crying,
No,
people are going
you
to comment.
commented. You commented way before that, sir.
What did I ask
Way
you? Go ahead,
before
repeat it back. Repeat it back in your emotional state. Repeat back what I asked you.
that. I'm not emotional. I'm just telling you, don't talk about me. Just keep my name out of your mouth. How about that?
Well, Rakia, I mean, if you're going to come up here and cry and say,
Yeah,
"Look, I just feel like giving up," I haven't.
Tell the audience I'm crying when they clearly hear that I'm not.
Well, now you're crying. I mean, now you're crying. You didn't
No,
come in
I'm
crying. You
not.
came in a little bit somber, a little bit sad. Now you're crying.
Not really. I'm not sad about anything.
Screaming? I don't know. I mean, how do men
I'm
react
not
when
screaming
women
about
cry?
anything.
Men do this.
I'm not
So real
screaming
quick,
either.
just
A woman would be
to
crying
record
with the
straight,
same
I gotta say,
emotion.
Kia brought that up, and he might be right that people don't agree with him. I agreed with him immediately. I did agree with him. I did say that would simply be a simple way to measure it. Just measure the drop from a horizontal line and all that. But true that most people they don't think that's
Nobody. I don't disagree.
but then people talk about like theodolites and stuff, and they say, and then lasers and stuff, and in those terms, yeah, I would agree that there's problems. You can't do it, but
Well, that's
dropping
the
from
point. People can measure it every day, right? So the question I heard asked was, people can measure, they can prove it, but they don't. That's not satisfactory. They're going to ignore it. They're going to throw it to the side, and you're going to rinse and repeat every day. It doesn't matter if you can prove it to them. They don't want that proven. They just want their time wasted, right? Or they just want to go through other theories and maybe what could be happening. Let's bend the horizontal line, so now there's no measurement. I get that, right? But but his point was, is it really worth doing? Is what it seemed like, but. Maybe I'm wrong. Maybe he's saying it's totally worth
No, but what do you think?
doing.
What do you think for all of us? Is it worth doing?
No.
Kosho is going to be here tomorrow, like Bacon or Tactical French Cat, not giving 1 inch. So I see your point. No thanks. I also see Dave's point. He has probably convinced lots of people to consider flat Earth and beyond. But here's the point: there's always a beyond, isn't there? There's always a beyond for us individuals to
Well,
consider.
he used like a different metric system, right? So he started saying how we're not going to be able to convince anybody here, and then he said I've convinced tons of people outside of here. So I mean that's the metric I was using. Yeah.
I never said that. I never said I couldn't convince anybody here. Never said
Oh, you
that.
did? Oh, okay.
No, you seem to be wrong again about me.
I mean, maybe I misheard you. Sounded like what you said was the people I love, right? I mean, I don't know. Maybe you love everybody here. I don't know. Is this love to you or just crying? I don't know which one it is right now.
Yeah, you probably don't. I didn't say anything about convincing just the people I love. I never said that.
Oh, okay.
Ricky, you were
So
probably talking about the likes of Kosher or Bacon. 1 second. He was probably talking about the likes of Kosher or Bacon or the continual sort of opposition no thanks throughout the years
of
where they're
course.
always here. Kosher will say the same story today as he said 6 years ago.
Of
That's
course,
what he's
but
going
we're
through.
gonna. But Rakil wants to pretend that's not who he was referencing. I don't know why. Just I don't know why. But he's gonna pretend that's not who
Wrong
he's
again.
referencing.
I'm not pretending anything. Do you have a question for me, sir? Just ask me. I'll tell you.
What's your favorite color?
Blue.
Nice. All right.
Anything else?
To ask you? No, you've already made yourself clear that you're wasting your
No, no,
time.
no,
But you're
no.
okay with
Anything
wasting your
other
time.
questions? Don't make
I have a
statements
No,
about
I
question,
don't
me.
have
Dave.
any
What's your
questions for you.
favorite
So
Right
movie?
here.
feedback,
Blue.
and when you put your thoughts out there, expect them to be analyzed and talked about. I don't know where you're confused about what you think's going on. You want to put your thoughts out there. It's okay to accept whatever you want them to accept, as long as it's a horizontal line over water. But everything else I say, do not talk about. I don't know where you think you are. I don't know what kind of platform you think you're on. I don't know where you're
I
getting these
never said
ideas that
that.
people don't talk about you. We can talk about you, man. You're out. You put a name on it. You put your voice out there. You're opening yourself up to be talked about. I don't know where you're confused.
Well, we usually talk about topics, not other people. That's where
Yeah,
I'm
why are
not
you
confused.
confused?
I'm not confused. You seem to be wanting the audience to think that I'm like this, doing this thing, like I'm confused, I'm emotional, I'm this, I'm that. Why are you talking about me, dude?
Yeah, I made it clear. You brought up the subject, right? And I thought it was a great subject. Raki is giving up. He said it's pointless, right? These are his words. It's pointless. It's useless. You'll never convince these people. You might convince other people somewhere else, but not these same people over and over every day. And I thought that
I
was an
never
interesting
said that.
topic you
I
brought up.
never said that either, right?
I'm extrapolating on what you definitely said.
I definitely didn't say it's the same people over and over again. Never.
Yeah, I'm
Ever did I say
extrapolating
that.
on what you definitely said, though. Yeah,
I never
nobody's
said
dumb,
that.
dude. Like nobody's dumb. We know what you're saying. Yeah, it's okay.
I never
It's okay.
said
We
that.
can read you. You can let it all out. We can read
Yeah,
you. We
you
know
can
what's behind
twist
those
it and
cold
make
eyes.
yourself. You can make yourself look like that. That's fine. You're
We know
allowed
what's
to do
behind
that.
that rough exterior. It's a heart of gold. We know.
It's not a rough exterior. It's the truth. It's my truth.
I know it's
Nothing
yours.
wrong about it. Again, you do you have a question for me? Because
No,
I'll
why do you
answer
keep asking
very
me
quickly,
to ask about
very
you? Why do you
adamantly.
want me to know more about you? Listen. Somebody
I
loves you.
want
Why do you want me to keep on asking questions? Somebody
nonsense
loves you.
about what you know about me and then spouting them over the air like you think you know me.
Over the
Like
air. Okay.
yeah. Quit
Like the
talking about me.
airwaves,
Talk
like
about the
broadcast to
topic.
everybody. Yeah, I got you. Like topics, if you bring them up, are going to be talked about by everybody because you're broadcasting them into the air,
I
over the
didn't
air.
bring up myself. I didn't bring up myself. You
Yeah, I
brought
didn't
up
bring you up
myself.
exactly,
What
right?
you
I brought
thought
up only
about
the
me.
point that you brought up. Listen, man, if you don't want to, if you run it back, you brought
Hey,
up your
listen,
emotions.
man.
That's okay.
Who
If you're
are
having
you?
some tough emotional times,
It's
that's
not
fine.
emotional. It's a
If you're not,
fact.
then you're not. I mean, I appreciate
It's
you
a fact.
clarifying it
I'm
with your
not being
feelings.
emotional about another man talking about me. I'm giving you the fact. If you want to know something about me and tell an audience something about me, just ask me. Just
Or,
ask.
but don't ask you at the same time. I
Well,
appreciate your
you don't
standing.
have to. You can just make assumptions and then spout them off to the audience if you
I
want.
got you, dude. Listen, settle
That's
down. You'll
your
be okay.
choice.
You'll be okay, man. I promise.
Yeah, don't worry about it.
Listen,
You don't have to
hang
worry
on, come
about me.
on. Okay,
Still
one
worried
second,
about
hang
me,
on.
are you?
I called for a compromise. Let's have an arm wrestle between No Tanks and Rakia. We'll
Come
go
on, please.
Yeah,
GoFundMe
the great mediator.
into Lake Pontchartrain.
Yeah,
Pete,
I don't arm wrestle anybody. I'm undefeated actually, but I choose my opponents carefully.
can you go left-handed?
I don't go left-handed. I'm right-handed. I broke my elbow last time, or cracked my elbow last time I arm wrestled.
That's how I
That
beat
was
people.
years
Is
ago. Let's
I can go
go.
both
You
handed,
played
so
poker at the time, Dave?
I just compete left-handed.
I'm all for that. Definitely someone who wants to spout their opinions about me, and then be wrong. And then I'm here. I'm telling you, you're wrong about me. I'm telling you, if you want to know the truth about me, since you're so indulged on knowing me or knowing what you think you know about me, just ask, man.
Listen, I don't want to soul search you, right? Like if you want to, I mean,
Good.
you're
Then
just
stop
resistant to it,
talking
man.
about me.
Go
You're
ahead, ask
resistant
him
to
a
it.
question. Ask him a
Hold on,
question.
guys, come on, guys, hold on. No Tanks is clear. He's clearly teasing you, dude, and you're kind of letting him do it a little bit. It's what he
No, I'm
does.
not sure about that. I'm ask Dave a
Almost
question.
there.
He's after answering Dave. He's after
No,
answering
because
No
I am
Tanks.
only
Ask
going to
him.
make. I am at this point only going to make fun of him. I mean,
That's what real men do. I mean, just go at it, man. Show your true colors.
yeah, I mean, that's what I said. I don't want to do it because at this point I would just be making fun of you. I don't really want to find out what's in your soul exactly, but I appreciate you sharing.
Thanks, man. Appreciate you. Hey, if you want to know anything about me again, I'll restate it. Just ask. Don't think. Don't have an opinion. Just ask me. Thanks.
Yeah, that's a fair enough conclusion.
Fair enough, Pete.
Yeah, I like that. I have questions to ask Dave. Hey, Dave, how can you be a gambler so much? You were talking about you're in a pot of. I could be a great poker player. I finished first in 10,000 online. What? Okay. How can you be a gambler and be a Christian man? That's
Show
my
me the.
question. I know you.
Show me one verse in the Bible that says gambling is a sin.
Exactly.
Go ahead. It's a
I
misconception.
think the 11 and 3/4 commandment, the ones that left out of the official Bible, is thou shalt not gamble.
Thou shalt not gamble. Show me that one. I don't know that one. I don't
That was
think
the
what I'm
11
doing
and
is gambling
3/4
either.
one that was left out.
Yeah, it's a skill game. It does have some luck involved, but it's not like the roll of the dice. It's like a golf tournament. You know, the better players are going to win most of the time, and they're going to get lucky and unlucky in that course of that tournament. It's pretty similar. But if you want to call it gambling, just that's fine. If you want to say I'm a gambler, that's fine. But show me the verse in the Bible that says gambling is a sin. I'm still looking.
Okay, let me ask you a question then. I actually already know it's a sin in a sense, right? I have a different view on sin, what sin actually represents. But let me say this to you. It becomes sort of consuming in a sense. This is where it is a crime and it garners your attention. Not you, I'm not speaking about.
Did he cut out for y'all or just me?
You asking me?
Well, if you can hear me, it must have
No,
been
I
him cutting
can't
out.
hear him. He cut out.
Yeah, I think he cut out. But yeah, I don't see anything in excess is a sin. You can work too much that takes away from your family or things like that, or takes your time away from your studies or whatever you want to say. However you say it makes a sin, but it says anything in excess. It mentions gambling that you should stay away from it if it takes you away from glorifying God or takes you away from your family, but it doesn't tell you it's a sin. If you want to say it's a sin, that's fine. But I don't drink. I don't go and play blackjack and gamble and go to these places. I just play poker tournaments and enjoy it. Right now, they're in entertainment. I used to play it for a living. I don't anymore. Pure entertainment, um, and I like it. I mean, there's a lot of Christians that do it. We have poker tournaments in churches. So I don't know. If you can show me though where gambling is a sin or playing poker is a sin, I'll stop forever. I promise you that.
Well, I could show you, not
Go ahead.
necessarily in the Bible, not
Oh, okay.
necessarily in the Bible. I could give you a rundown on how, especially internet poker came about and how it was all a distraction from 9/11. So now we have different things to think about in more immediate concerns. And I'm not talking about you again, Ricky. I really am not, because I know that you carry the whole of the weight. You know what I'm saying? You walk the walk and you talk the talk. I'm definitely sure you've convinced
I
people
am not
to
ashamed
to
of what I do.
to return to God and the flat Earth. I'm definitely sure you have. I'm not criticizing you in that sense. All the Bible commandments are just general guidelines. You know what I'm saying? So in general, that's how gambling is negative thing, and I'm sure it has to be mentioned multiple times in the Bible. Go ahead. I have problems with my connection,
I'm
maybe.
meeting people in the
Sorry about
restaurant, so I won't be available for a while.
that. What's his name took a gamble with his son when God asked him from the clouds, maybe from a whirlwind, to sacrifice his son. You know, maybe everything is a gamble. Maybe gambling is strewn throughout the Bible in a sense. Maybe we live every day gambling to one degree or another. But what's the outcome of the gamble is, well, if you're just gaining more money, everyone who loses, well, everyone wins. You know, there's an interconnection, interrelationship somewhere down the line. Anyway, yeah, that's all. I'm not criticizing any individual man's choices, just generally. Never gamble your neighbor for his house, but someone you're after winning over an internet table, incognito, they could have stolen from their grandmother. Anyway, I think I'm disconnected, so sorry about that. Let me reconnect.
Hey, Kosha, are you still in here?
if you do much to win chips at the end of a poker table from your fellow man, won't you do lots more to win the ultimate prize, which is, well, the promise at the end of the Bible, which is what? The city of gold, most valued or prized possession. You forget we're not the material, you know? And as I said again, for every winner there's a loser. But you don't consider these things when you're talking about online or poker, different with friends, of course. But yeah, in serious competitions, you just don't know what someone has gone through to get the stake in the hope of making it big, that sort of thing. So in that sense, I think it's bad and it's morally misaligned. Finished first in an online poker competition of 10,000. And I have some money now, actually, a little bit. If I wanted to, just but yeah, out of that money, I could make 1 million. I think pretty easily enough. Just careful consideration, playing the odds. Is that the route to happiness? Is that the route to fulfillment? Is that the route to unity? I'm not sure. I'm not sure. I'm teetering on the edge. By the way, yeah, Kosho, where are you, bud? Someone referenced you there just a second ago.
Well, what's taught, Pete, in the I guess in the Bible in a way is that if you don't have money, it's because you're not ready for it. It's just like a progressive growth. Yeah.
I was thinking about this today, my friend. No thanks, which was King Solomon. Why did Solomon descend into demons? Solomon buildings in 9/11. Well, I mean, do you know how many wives Solomon had?
Well, how much can I get for him? I don't know. No.
Yeah,
Bunch.
but I mean, he had over 600 wives. At what point did God, let's say, if we're taking it literally, get sick of it and say, "Hang on, bud, this is a bit much, isn't it?"
That's
But he
not, yeah, but you're
delves.
taking it the wrong way. What I mean is, the money, like the income, is a responsibility, right? So, like, if you're ready to grow into the next responsibility, right? Putting it towards like God's work, right? The money, like, if you put God first, you'll get money because you'll be ready for the next responsibility, giving God back what is God's, and then you'll be tasked with the next responsibility. So, if you don't have money, you haven't passed. You haven't passed like test number one, putting God first.
And God we trust is on the money, isn't it? I get your point, but it's all within this artificial surround, and it goes back to the nature, the true value of money. We know we deal in debt currency, but even coming to the greater true value, we're brought back to gold. Well, the city of gold were promised in the Bible. City of gold to dwell there. I don't like the thoughts of that, man. I prefer nature. City of a natural setting with trees and animals, fawning around, whatever. But yeah, my point is about the material reference. That's why I mentioned Solomon and, well, all these riches. But here's the thing: the material, the matter. He had all the women. He had all the women. He descended into
I know you keep
complete.
saying that though, like it's a achievement.
Yes, but no, Solomon didn't exist. It's a
What?
consideration for us to see why he got in touch. That's why I mentioned it with the demons. Why he had all of these sort of demons at the palm of his hand. The demon is the woman, the woman. But yeah, that's why I was bringing it in that sense. Not something outside what you can relate to, but something that you can relate to, which is a deviation away from the material only realm.
As weird as what you said is, right? I mean, it is parallel to what I was saying, which is that it's a responsibility, a burden, right? Like something that that is what I was getting at. It's not an achievement or a reward. It's now a burden and a responsibility that, I guess, in that story, he showed himself he was able to take
Oh,
on.
I would say to you, no thanks. The way I look at it, anyway, there are people in the know And the best you can do is lead your own path and understand and figure out these basic core principles of the creator within and their significance within your own existence. And you can choose then with your will to follow that path or not. So whatever you're destined for, yeah, that's down to yourself. Me, myself, I'll just say I have no affiliations. So I appreciate what you're saying in words, but I can't appreciate it in a different way because I've never traveled that path.
Yeah, I mean, yeah, it's just, but I appreciate what you're saying as well. You're saying that you know, what you initially said, like, what's the purpose, right? Like if somebody were like to have a bunch of money, right, and they get at this like I don't know crossroad where they're like, well, should I build? Because if I build, I know I'm going to have to, you know, have these new goals, right? They're going to have to have these new purpose, right? If I build, I have to move forward. But I don't want to get less because I'm comfortable for with what I have, right? So I kind of want to stay where I am. How can I do that? Maybe I could gamble all my money away, and then kind of break even and just keep, you know, kind of just stay in this medium place where I don't need to grow any further as a person, you know. So
That's what I'm, listen, that's the crossroads. Remember, I said I was teetering on the brink in a sense. If all of this was to continue on, my friend, for another 10 years or 20 years, um, that's the way I'd make money. But gambling, just to take me towards a greater path of forbearance, I guess. Just live out my life. Still know that there's a greater divine plan or creator's plan in play, but yeah, I'm not criticizing it in that manner. But yeah, I think that the best thing we can do now, the greatest riches lies within your word or your kind word, and that's all I'm talking about. Just your children, your family, your friends, the people you meet, spreading the
yeah,
truth.
that's what all
It's a
the
big
broke
one.
people say.
There, Flat Earth is a big one, of course. Flat Earth is a big one. Many people have you told about the Flat Earth Co-Show? And that's the loss to humanity that you haven't spoken about a Co-Show in all your wild range and your wide ranging, you know. Imagine you were passionate about the flat earth and we've been lied to. You could spread the word like wildfire, then who knows? It could progress. Maybe that's the true currency, isn't it? The truth currency. Very good. Anyway, one of these days I'm going to get to sing a song on Geos again. I was thinking about a long, long way from Claire to hear my own particular version, but maybe for a different time. But yeah, truth currency, I like it. Kojo, now that you're back, I think you're back anyway. No thanks asked question bit back. Maybe if you are back, you might reiterate it and you might be able to answer.
Yeah, what part of Jersey are you from, Coach? That's my question. I'll ask him when he gets back.
Oh, sorry about that. No thanks. I actually thought that was him. I don't have earphones here, so I might seem a bit rude at times, but it's not just coming as immediately through to me as maybe for others with earphones. But yeah, I thought that was him. So he'll be back when he'll be back.
Hmm.
Not from the old Jersey, from the new Jersey. Do you notice the way 9/11 is sort of in the air these days? No thanks. I don't want to force you into any specifics or anything. But we had the 9/11 reference with the Hawaii and the directed energy weapons, which destroyed the whole place, and there was 1,000 missing children or something like that. And then we have the 9/11 22nd remembrance, where a guy jumped in who was 33 into the memorial fountains. But now we have the Israel, what do you call it, Palestine conflict, where originally it was Israel's 9/11, and then it was compared to Palestine's losses, and they had 100 9/11s or something like that. What do you reckon? What's going on with all the 9/11 references? Do you think 9/11 has ever left us?
Um, I think that bad things actually do happen in reality. Like people get hurt, car accidents, people die. It's not like somebody planned to hurt them. I also do see the connection, and it's just I don't know. All these things going on right now. Coincidence? It's not like you say coincidence, but are they being fueled? Do we fuel each other's energy? Like, is it just like out there like negativity breeds negativity? And that's why there's multiple wars on different fronts right now. I couldn't tell you if it's a master plan or not. But these are people who are dying in reality, suffering, burning to death, suffocating to death, drowning, being shot, watching somebody they love die right next to them in reality. Yeah.
Yeah, for sure. Real shit happens. Part of it, isn't it? Maybe everything's predetermined, but we're talking about decoding or at least reacting to sort of mainstream news that's presented across different positions over this stationary flat earth surface enclosed. So what are we to make of that? What do you make, for instance, of the whole fakery aspect, the connector, the ninth ring to all of this, the 40 dead, what are beheaded babies, fakery is called, some of the Palestinian rubble images where you have animatronics or rubber, uh, uh, you know, parts.
What I know is that what I know is they speak in a language that I don't understand, and I'm not going to understand it. I mean, I know language itself is this like accumulation of vibrations. It makes a sound. These letters are put in a way that make a specific sound that has a specific reaction. Just numbers. There's not that many numbers to I mean, there could be. There's just a different language that I'll never. I don't think I'm going to ever be able to understand it. They communicate to each other pretty obviously, but I can't read it. I don't know how to read it.
Do you think you can't read it though? I mean, do you think in words? Have you your own language? Letters are the basis of words, and well, the basis of letters is the thought, isn't it? So some sort of immaterial representation, art, if you want, But yeah, why do you think you'll never be able to understand it? Maybe you can. Maybe it's easier now to understand it than ever because there's a different setting for
Yeah,
everything.
understanding is an interesting word because understanding is something that happens without words. Right? Like it's you understand, and you don't even have the words to describe it, right? So it's something different, for sure. Yeah. But yeah, you're talking about decoding something. I don't know if they even have the this leg up that you think they have. I don't know if they have this power that you think they have, or if they're just trying to work within um, the language that is within nature, and they just kind of and you're seeing it as a pattern that they're putting out, but they're just working within nature that puts out a pattern. So I don't know which one it is. I'm not going to understand that.
Maybe they're through their own language speaking to you. Once you see beyond their different layers of representation, you can somehow come closer to your greater awareness and sort of appreciation of a greater overstanding. That's maybe the only path to go. Otherwise, the way I see it, otherwise it's hopeless. What are you going to do? Live out your life?
What's hopeless?
Well, unless there's a greater puzzle in play, or there's a greater path to sort of acquire, it's hopeless. There's no God in a sense. Our life is just immersed within ignorance, and maybe death holds the key. But throughout life, then, if there's no hope of any progress, it
I
sort
don't know
of
where you got that from.
makes.
I'm just saying you're putting out the idea that the I don't know the controllers of this world, which are they do exist, whoever they are. There's somebody in control at all times, right? I mean, by default, next man up or whatever. But you're putting forward the idea that that they know exactly what they're doing. I don't know if that's true. You know, you're
Well,
putting out the idea that
it's
they know
more.
exactly the cause and effect relationship that's going to occur when they perform a specific, I don't know, like atrocity or kindness. That they know exactly how to weigh it within the system that you know all creation exists. So they know the cause and effect without a doubt. I don't know that's true. I'm not giving them that much credit.
Yeah, but I agree with you, and I think no matter how up the ladder you are, there's always areas you don't know. This is why I think that there's in the Bible, even the elect or the elite may be deceived. But um, I think that there's a greater sort of script laid out for you to read, the genuine. If you join some sort of an affiliation and you're let in on greater truths which apply to all mankind, well, you're after compromising yourself somewhat. You know what I'm saying? So I'm saying if you haven't done that, there is hope. You don't have to rise to the top of that particular group's ladder or other groups' ladder in order to get to maybe a greater truth which applies to you and your life and your love, whatever. So I think
Yeah,
that's where the
you don't need to go
creator.
through men. Yeah, not
Let
at
me
all.
just say, that's where I think the creator and the greater faith in the creator in his creation has with us, especially now. Sorry, go ahead. Go ahead.
Yeah, I see you. It looks like it's a pattern that you do. You look to men for like what are they doing? They're up to something. Let me decode what they are doing. Uh, I don't think that I think you're giving them too much credit. Is all is saying that. And then I mean on your other topic that you kind of touched on was that I could say two things. I believe in like destiny, fate, and free will. I don't know how, right? Like how's there destiny and free will at the same time? But there is. I can't explain it, but there is.
Yeah, me too, bud. And let me just say this to you. I don't mean to be preachy or anything like that. We're all on our own this adventure to a certain degree, but at the same time, we're all sort of together. But yeah, it's a recognition that there are component parts within us. We have the mental, we're talking about the mental game of chess. We're trying to work out via non-direct experience all of the different clues or decodings that are presented to us. At the same time, we live our harsh, real reality within the physical sort of surround. So yeah, it's all about or coming to recognize the greater context for our life, and of course, every flat earther and beyond will openly and immediately admit that. But now coming to greater, of ever finer terms with the distinction or the placement within the surround. And that is well within ourselves. The mental is in the brain, the physical is in the. Now we have the heart. The heart is the bridge. Then, so within a proper context, we can reconnect everything. That's what I think it's about.
Yeah, but you have to stop talking to do it. And I'm not even saying that as an insult. What I'm saying is that you recognize that there's like some kind of coding within language within, right? We're sitting here we're trying to decode it, right? But the language itself is like a deception, I guess you could say. Like speaking and is a deception. Understanding doesn't need to be spoken. You just understand. You can see something and understand. You don't need to. It doesn't. Nothing needs to be spoken to you. So we're working. Especially you, see, with the decoding stuff, seem to be like working within the deception to try to figure out what you're only going to figure out if you stop using their language. Just sit there. I mean, people have said it for a long time. Like meditate. Like shut up and meditate. Say stop talking. There is a cause and effect with you know the way words are pronounced, what is said. There's a relationship between sound and frequency and nature and etc. Right? It goes on. So what I'm saying is stop talking, and you'll figure it
Yeah.
out. You're not gonna work your way. You're not gonna talk your
Well,
way
well, one
into figuring
second.
it out.
I have a brilliant response. I have a brilliant response. I'm sending letters, and letters they always get burned. It's not like movies, they fed us on little white lies. Okay, that's my response. Stop sending letters, they always get burned. I agree with you. The letter,
And then,
the word is an extrapolation on the thought, but we can't help but think in terms of words. You know what I'm saying? That's outside of our dreams. But yeah, this is the sort of the barrier that we have to bridge. And that's what I was talking about a chess game, no tanks. Honestly, it's like it's a sort of a mental exercise. So it's a greater application of that aspect. And of course, then there is the physical, where the foundation, the foundry of the physical lies below the heart and the gut, the generative area. So yeah, it's about coming to greater terms. So I can appreciate what you say. And I always said that you can transcend any of these considerations just by taking appropriate medication, let's put it like that, or as you suggest as well, maybe forgetting all of the words and the letters and just yeah, encompassing greater surround and getting greater answers, knowing it,
yeah,
knowing
I
it,
don't mean to
rather than
complicate it
working
too
your way
much. It's
through
just,
it. Yeah.
there's like a saying out there: the more you know, the less you know. The less you know, right? Like the more you know, the less you know, right? So it's this. All I'm saying is that, in the simplest way, is that all this talking is is part of what's hindering everything. Talking is part of the problem. Language is part of the problem. You don't need to say any words, like, to understand. You could sit, meditate, and you'll understand after a long enough time. Sit, fast, and understand. You'll get it. But
Right.
and how is it communicated? It's communicated in a different way. That language just obstructs that receiving of the message. Yeah. So.
But now we have to get everyone on board, and that's the problem with this transition period, isn't it? Is how to bring everyone on board. And well, I think it's happening, of course, and everyone in their own way will come to the same conclusion, and maybe we'll all arrive at the same point, which was predestined for us, even through all of the conflict.
Yeah, if I was to make
So I'm with you.
yeah. Yeah,
With
if I was to
you.
make a case for what I said, like, people feel good when they wake up, typically, like, feel refreshed, their mind, right? They didn't speak any words when they're sleeping. People typically, they say, I don't know what it is about church, but when I get out of church, I just feel good. Maybe it's because you bowed your head and you shut up for once, right? Because as soon as you're out, you're talking again, right? And I could probably run through a few other situations where the same effect happens. Like when you stop talking, you just, be silent. Purpose can, like, reveal itself almost, right? But
Pete
you have to say.
can't be silent, man. That's impossible.
What? Get out of town.
Just
Yeah,
fucking
but
with
hang
you,
on,
Pete.
hang on.
Just fucking with
Hang
you.
on. If I was silent, me and No Tanks were silent, we wouldn't be here. So we're in
That's
a
right.
particular, yeah, we're in particular furnace here, if you want, and maybe our words speak louder, are more voluminous than we might ever have imagined. They might reverberate through 4D time and space. Who knows?
Hey, I love you, Pete, man. It's been a long time, brother.
Nice one,
Just want to
bud.
say hi. That
How
was
you
it,
doing?
man. It's good to hear
I'm
you,
going
man.
for a
I'm
smoke of
like,
a joint out the front. 420, God's
ah,
gift, man. THC.
hey, Aristarchus, Aristarchus. Love you, man. Keep it up, Pete. Don't ever change, man. Don't ever change, brother. What the fuck just happened, man? Is this thing working? Yeah, maybe it's not working. Fuck, I don't know. Technology doesn't always work. I can't hear shit, so I get deafened. Maybe I got deafened. Shit. Tough room. All right. Carry on, boys and girls. Carry on, man. Not working? Damn. Okay.
And Bacon just keeps fucking around.
What's up, Bacon?
Yo. So,
What's up, man? What's the latest?
no news.
You got good news?
No, I said no news.
Do they not have the 24/7? They just have the politics now.
I don't know. Yeah, I think there's no one in the old 24/7 anymore. Is there anyone there?
Yeah, they.
What did you think about my Eclipse argument there?
Let's hear it.
Well, I found out like the totality path of the eclipse that happened in October 14 using the globe. That was like a very good match to time and date. Yeah, that's it. You can use the globe to know where the path of totality is going to be.
What do you think, Gio? Is that proof of the model?
Well, maybe it doesn't prove the model, but the fact that you can do that would be quite surprising if Earth was not a sphere. At least to me.
What do you think it proves? Maybe it proves. Maybe it proves locations are accurate.
It proves the globe is accurate to determine locations of a eclipse totality.
Well, let's see how you would answer to this. So, what assumptions are you utilizing throughout that process?
Great question. So
this will be a name the assumptions
right.
game show right now. So you have to.
Right. Yeah.
I also
have
have
to-
a question. Are you
Yeah.
drawing straight lines to stars?
There are no stars in my
All right,
calculations.
my
Only
bad. I have
moon and
no
sun.
idea. I came in blind. Sorry. Carry on.
Okay. My assumptions were that the Earth was a sphere, that its radius was 6,371 kilometers. So assume that the Sun and the Earth were 150 million kilometers away from each other. Let me see what else. The Earth was a sphere, of course, like a perfect sphere. I didn't account for oblates or none of that. Also assume no refraction, so just straight lines for where you see things. What else? Oh, that was basic. Oh yeah, and assume the data in the nautical almanac was correct.
Even in your own model, those assumptions make your model wrong. Like,
What do you
there's
mean?
refraction.
Oh
Maybe I
yeah,
heard you.
yeah.
And it's not a perfect sphere.
Right, but like,
Hold on. What is this?
don't think refraction is relevant for totality path because all that makes is like refraction would loom up the position of the eclipse, but where it would be seen as total wouldn't change. So if you're trying to find the path of totality, then the refraction shouldn't be an issue. Shouldn't throw off your prediction. And
This is an
it
eclipse.
didn't.
We're
Yeah,
doing eclipses.
yeah, the
Okay.
totality path. Yeah.
All right. What are the assumptions? Like Gio said.
I already listed them.
I
Yeah.
missed it.
Earth.
Yeah, can we
Right.
go through
No
those again and
refraction.
maybe one at a time because that was well
Fair
laid
enough.
out there.
Fair enough. Fair enough. So, perfect sphere. Earth is a perfect sphere. That was one of them. The other one was the radius was 6,371 kilometers. The other one, the sun is 150 million kilometers away from Earth. Oh, what else?
The
There's
and
more?
yeah, there's more. There's one more. Oh, there's two more. The no refraction, so light going straight lines. And the last one is that the data in the nautical almanac is correct. That's the last assumption.
And that the distances between the locations are correct too, right? Distances as well.
Not really. You can change the distances. So, for example, you can turn that prediction into an A map, which would change all the distances, but the coordinates of the totality path would remain the same. So, like the cities where it would happen and when, that wouldn't change, and that's what I was calculating for.
Oh, that would change though, because like what you would. Oh, sorry. Go ahead. Well, if you want it. Well, I mean, what one person would call Chicago, Illinois, and then somebody else would say New York City, and then the distance claimed, and then how those map is going to connect to how those locations are going to be linked to the sky. So it is another assumption, but you named, how many was that? That was like 7 or 8 of them.
Oh, let me write it down so I
lost
know
track.
exactly how many.
Yeah, somebody.
Okay, I'll write it down. Yeah, I'll do it. Don't worry.
Well, I mean, it essentially was like the whole model, like that the Earth is a sphere, that the sun is 93 million miles away, that there's
Some of the assumptions you made. Some of the assumptions he made they're not even true for his model though. Earth being a perfect sphere, drawing straight lines of celestial objects.
Refraction not existing. Refraction is never not existing. There's always going to be some, even if it's very minimal, especially over long distances. If we're talking about that kind of, there's always going to be.
If we're drawing
over miles of distance.
Yeah, if you're drawing straight lines to the moon, like if that's what you want to do, we can start drawing straight lines to moons and suns and shit, and your shit will be all fucked up. We can debunk the radius that way.
Oh, the point
that was
here
another one.
Is
the radius. He said was an assumption.
Yeah, the point here is to get a prediction, and I'm simplifying stuff that are not that relevant, so I can get a prediction. And of course, the prediction is not going to be perfect. Not perfectly loyal to the model if I'm not accounting for everything, but I'm accounting for the most relevant thing. So even if the prediction is not exactly what the model should tell, should still be very close to what the model should tell. If that still matches, I think that still counts as a win.
Yeah, Bacon. I mean, if you're making these assumptions, it's a lot of assumptions, buddy. But if you're making these assumptions and you make the correct prediction, I mean, I might be crazy, but doesn't that say something about those assumptions? Like that those are correct assumptions to make if the prediction is correct?
Or at least they're very if those assumptions are wrong, the reality should be at least very similar to those assumptions because the prediction was very similar to what actually took place.
Right. So I guess it doesn't matter how many assumptions you make. You can make 1,000 assumptions. If your prediction is correct, then it says something about those 1,000 assumptions.
Yeah.
That's not necessarily how that works. It's actually the opposite of that. If you have assumptions baked in, then you can use certain correlative geometries to build a false model of reality that has a correlational geometric transform in which they both will equal out to look the same, but actually the one of, in this case, the model of a sphere is actually not what the Earth is. And it's like the devil's in the details. Oh, there's that. That phrase, the truth is in the details, as well. So in terms of how that actually maps out. So just because they can build a globe model and use geometric transforms and then claim that there's some similarity of the way the sky is moving to what they claim the ground is and what they claim the coordinates are, that you guys are having to take on assumptions along with all those other things, can fit a model that is reverse engineered from how our vision works and how our experience of reality is. That doesn't mean that actually is aligning with any type of validation that the Earth is that model that they're using the transforms in, and then using various assumptions to bake in certain parts of it that I think you guys that go with this are not able to see through currently.
You're saying Bacon has baked in some assumptions?
I don't know if I'm not saying he did it, but all of those assumptions, just because they correlate with what you might call a prediction, the thing is there's certain ways in which in those assumptions, the actual difference that would need to be changed between a planar surface and a spherical one is at a threshold that, along with the GPS and the control of a lot of the land on Earth, that they've been able to do to convince people that we're on a sphere, even though it's just a reverse engineered model of how the sky works ultimately.
Yeah, I listed the assumptions. It's 5 that I could think of. So
5?
Earth is a perfect sphere. Yeah, 5 assumptions. Earth is a perfect sphere is 1, and radius is 6371 kilometers. Third is no refraction. Fourth is the distance between the Earth and the Sun. And the fifth is that the almanac data is correct. I think that's all you need. I think you need more than that.
Dude, that's like every part of it. That's like
there's a lot more.
That's like the model and the sky, because the almanac's connected to the sky. You're literally every single one of those assumptions is every single thing that you would have to assume if you were ever to assert that the results had anything to do with a spherical Earth. Those assumptions are all the reason that's even being asserted, is that the assumptions allow for part of it to work and for the back door of what they're doing to not be revealed, at least on the surface.
But let me ask you a question, man. How do you make? Let's say that you don't know the future, okay? And let's say that you make assumptions about certain things, such that this thing will happen. So you predict the future based on these assumptions. I mean, isn't the value of the assumptions based on the predictability that they make? If you make a correct prediction, doesn't that make a strong statement about the assumptions you made? I mean, I don't see how that doesn't follow.
I would say it may or it may not. Depends on the context and the specifics, but of course that could make a difference. Yeah.
Who hit him with the Law and Order soundboard?
That was Dan. That was good. It's good timing too. But really, no. But I mean, honestly, I mean, this is the thing that really it comes up a lot, that I feel like a lot of people don't give credence where credence is due. The predictability of something, like nobody can read the future. And if someone's able to tell you the lottery numbers in the future, or someone's able to tell you exactly when something's going to happen or where it's going to happen, and the information they use to make that prediction, you have to give value to that. Otherwise, I mean, like, how else are they doing it? Unless that information is based on the truth, right?
No, negative. There's a clock on the wall, and I make a prediction that the big hand and the little hand are going to be at 12 at this time. So we can both make that prediction just from watching it.
Yeah.
However, if you try to say there's little midgets cranking a wheel, turning gears behind the wall because we can't see the inside of the clock, you could be wrong. Even though your prediction was right, you could be wrong.
That's 100% correct. Here's the missing you're missing. I didn't use midgets to come up with that prediction. So that doesn't make any sense. Whatever I used, you know what I used to come up with that prediction? I used my past experience with clocks. So that means that my past experience with clocks has to be based in reality, has to be correct in order for my prediction to be true. Whatever I used to make the prediction has to be based in truth in order for that prediction to be somewhat true. I mean, that just follows.
And this prediction of the
It doesn't
totality
follow.
path, like
Go ahead,
of
Bacon.
all Right. Yeah, I brought this argument to 24/7 to other people, and the first response I always get, well, not always because I didn't get it here, but usually the response I tend to get is several cycles would predict eclipses thousands of years ago. But I mean, obviously, like there are repeating patterns in eclipses. So every Saros, you get a similar eclipse, and people notice that, and that's fine. You can use that to tell when the next one's going to happen. But that's not what I did there. What I did there is to use not previous information about any eclipse. All I did was to use like the globe model, so the heliocentric idea, plus data that doesn't come from previous eclipses. Like it's data, current data of the sun and the moon at that moment. So I mean,
You use
everyone
the
has access
midgets.
to that.
You use the
No,
midgets. Everyone had access of looking at the clock.
well, no, I didn't because I did use my assumptions that I tell you to get that totality path. If you change those assumptions just slightly, like if you change the radius of the Earth, you add a 0 there. If you change the distance to the moon, if you whatever you play there, will affect my prediction, right? So my assumptions were really the source of my prediction, not like you just notice patterns and you're attributing to them to some random thing. It's completely not analogous to actually getting the prediction, deriving the prediction from something, not just claiming it.
You
Midgets are
use the
just being
midgets.
claimed. No, you're not deriving the prediction from the midgets. You're just saying you think the midgets are doing that. Well, the pattern's
All
already
these
there.
assumptions, bacon. All the assumptions you're making are the assumption of midgets.
Completely not
Could be
analogous.
midgets. Maybe it's just gears. Maybe it's a pendulum swinging. You don't know. You got this midget assumption you're going with, which is the globe model.
Yeah, but if you change that assumption, the prediction changes. If instead of midgets you say invisible unicorn, that doesn't correlate to a change in the prediction. So obviously that doesn't have anything to do with the prediction. So there's no credence to midgets if the prediction gets fulfilled because that's not where the prediction came from. But in my case, it is where the prediction came from. You can change those values, you're going to see the path changing.
This
So
is
you're
this is what it goes.
Yeah, I'll go since there's an awkward silence now after three people. So you're saying you couldn't create calculations to make the prediction come true of position and time over a flat plane? I don't get it.
Well, maybe you could, but is anyone ever did that?
Yeah, but so
Wait.
what's your point again?
Every
Well,
day.
if the Earth was flat, you certainly could, but I haven't seen it. And if Earth was flat, it would also be weird if you could do that on a globe, which I did.
Yeah, but you'd have
So
to
his whole
change your
point-
calculations. You'd have to change the formulas that you use to calculate the time and position.
Yeah, but his predictions were based. He listed like 5 predictions or 5 assumptions. His assumptions were like the size of the Earth and this and that, and so that was how he made the prediction, and the prediction was correct. So those 5 assumptions, those 5 things, he used those to get the correct prediction. So if there's another way to do it, then those other things, could be flawed in some way, but so far that's the only way to get the correct prediction.
Well, no, but you have to be making formulas to calculate using those assumptions, right? Like you have to be plugging in the radius to a formula that you made up to use a radius, right? Or am I wrong?
I'm not making respond because he's the one who.
Yeah, I'm not sure.
I don't know if
That's
he's wrong
all, man.
because I'm not sure if he's wrong because I didn't understand what he's trying to say there.
He's saying that he's saying that you not only did you make these assumptions, but you used the assumptions and you plugged them into formulas that could have also been, it's like you created the formulas to use these assumptions, and there could be manipulation in that as well, something along those lines.
Well, I didn't manipulate; I just did the formulas that you would use if that was the case. Like if you had the Earth and the Sun and the Moon being like spheres orbit each other, like if you had those assumptions, and I asked you, well, where would the shadow be if those under those assumptions? They're just straightforward way to answer that question. So the formulas that I used were pretty much that straightforward way to figure out where the shadow should be if those assumptions were correct. And it turned out that was where the shadow was.
Okay, but I guess reverse it. Say my assumptions are that we're over a flat plane and everything circuits above us. Could I write formulas to make,
Definitely.
and we know, yeah, okay, well, there you go. Definitely.
Yeah, but those predictions would have to be fulfilled for that idea to be valid. That would also have to give the correct totality path.
You mean like all of plane surveying? How the Earth is all surveyed as being planar, and then you have the sky that would be above that planar surface?
This is a bit of a different thing. Like we're talking about predicting eclipses. I'm not sure how to place surveying there.
Well, it is linked in, but I mean, yeah, we don't. I'm not trying to change the topic. You guys stay on what you're on.
I don't think you're predicting eclipses that haven't happened before, though, right? Are you saying you're predicting an eclipse that's going to happen 100 years from now that's never happened before in a position in time that's never happened before?
No, I'm saying I can tell the totality path based on the ground position of the moon and sun.
Yeah,
which is something that's taking place during the eclipse.
I got you. Yeah, that's just. I think that could easily be formulated, right? Like that's just the math part based on the parameters. Like if I give you a set of parameters of how tall my house was and what pitch I wanted my roof, you could write a formula to tell me how long the rafters should be and what shadow they're going to cast on the ground when the sun is at 30 degrees. It's just the math part of it. I get what you're saying now. Not even quite sure that's predictions because if it's happened before, and what happens every 18 years or it skips, it happens 18 years and it moves over 10% or 10 degrees, then, that's not really a prediction. You're just mapping out what's happened in the past.
That's all I did. Like I didn't see anything about any previous eclipse. All data I used was like the coordinates where the moon and the sun were overhead during the time of the eclipse. That's all I used. I didn't use any other information. So if that information exists and it's out there and it can be used to predict next eclipses, that's fine. That's just not what I did. It didn't have that information. It didn't use that information.
Okay, so what you're doing is you're drawing straight lines to the moon and the sun.
I'm drawing a straight line between the sun and the moon and seeing where that straight line intersects the Earth's surface. So that will be the position on the Earth's surface, where the moon will be right in the middle of the sun. That's where the eclipse is total.
So you're not drawing straight lines to the sun and the moon?
I just said yes.
He's taking all measurements on the ground as assumingly correct. And then that's mapped within a larger set of coordinates that he's given and hasn't verified. And
I know, but if we
the geometric transforms as to why it lines up, because there is the idea of a celestial sphere essentially can be transformed. But yeah.
Yeah, but if we draw straight lines to the sun and the moon, we can debunk the radius like that. So I don't know why he would want to do that. That's crazy.
Can you elaborate?
What do you? Yeah, a Selenelian. You want to use eclipses? A Selenelian eclipse. We'll draw straight lines to the sun and the moon. And
yeah,
boom.
that's not going to work for them.
That's just one example.
They need to not have straight lines for that one.
Oh, let me see.
Very bent. If you
well,
could even that doesn't work.
Even though I understand what you're going with that, can we take a look at an example of that, see if that's actually true? Because I haven't seen any footage of a Selenium where there's enough information to tell whether or not that would be possible on a globe. There might be, but I just haven't seen it yet.
Well, both the sun and the moon are exactly 180 degrees from each other celestially. So they're exactly
It's
180
only
degrees. Hold on. Well, I'm saying at the moment it's exactly 180 degrees opposite each other. However, they're both visible above the horizon. So on a globe, it's not possible.
they're only exactly opposite when the moon would be exactly in the center of the Earth's shadow, right? Which is a pretty wide shadow, so you can have the moon getting into the Earth's shadow without being exactly opposite yet, right? So, I mean, let's take everything into consideration and see if with straight lines that's still not possible, because I'm not sure if they have been verified. Even though I also don't think straight lines are going to be perfect predictions. Like the Selenium might not match that. I can see that coming.
Well, dude, as far as I know, virtually everyone in the entire globe community on all levels abandoned that back in like 2016 once they realized that it just completely does not work. And then that's why they always go with saying that it's essentially just refracting and bending around the sphere.
Well, I'm not gonna rely on their response because I've heard Globers giving the incorrect responses many times in the past.
Yeah,
Bacon always corrects them when they do that too. He loves to correct Globers.
For example, there's a very common response from Globers that is wrong. I was talking about one before, like with the upward accelerating Earth, but with the Selenium, like
are you argument policing, Bacon? Are you out there policing the arguments?
Little bit,
a little bit. Hey, you're saying the wrong. That's funny. All right, so go ahead.
Yeah. There was this guy debating the Selenium, and then they said the shadow was in the wrong place or the shadow was upside down, and he tried to argue that that was because of refraction. That's completely the wrong answer, and I have heard it like at least twice being argued by Globers, and that is completely wrong.
He's right about that.
Anyway, yeah, the Selenium. I
would agree, but that has a whole bunch of other issues with it, though. But I would agree that if they're saying that, that's well, actually, some have said that, dude. They don't really have much explanation for that one, like ever. Kosho has tied his mind into a pretzel, into a knot of a pretzel, trying to get that one to work. It just can't happen.
Yeah, for the shadow in the wrong place, that's easy.
Very simple.
I mean, yeah. It's just a bad assumption.
Take us on a journey through the pretzel ride.
Just about which direction is the moon's entering the node. The moon can enter the node from above or below, depending on which direction it's entering it from. Is depending on where the shadow's going to end up.
Yeah, we tend to assume that the
absolutely does not work, because if you have sorry Bacon, but if you have like the 5-degree tilt, when it's in that zone, it's already like when it's near to the node, it's already within a degree, well within a degree. So the little bit like between right before the eclipse happens, right after the eclipse happens, imagine the entire 5-degree tilt of the node. Imagine it's all the way at 0. So that's why the eclipse is happening. But it's like 0.03, 0.02, 0.01. You know what I'm saying, dude? Like before and after, it would only be moving a fraction because it takes a very long time for that whole 5 degrees to even happen. So it's not just moving in that explanation, like because it's not that much movement at the actual node between the ecliptic and which is what the lunar nodes are, between the ecliptic and then the moon's orbit, the planes of them. So that explanation does not work at all. If I didn't explain that well, I can try it again. Sorry, but
guys, straight lines. Guys, straight lines to the sun and the moon does not work on your model for so many reasons. The Selenium eclipse being one of them.
I'm not
sure. Before we move on, hold on real quick. So hold on, just Kosho. You're saying okay during this. Let's just go on just before we move on. Okay, let's just start from the beginning. There's an effect when we look at the Selenium eclipse or actually multiple different lunar eclipses have this, where the shadow, quote unquote, or the black thing, whatever it is, or the dark, that whole affected the dark, then it turns red, and then it kind of, all of that. Okay, so when we see that effect, sometimes that black thing, the dark thing, comes up from the bottom. Sometimes it comes in from the side. Sometimes it comes up from the top. And then it does various different like phasing basically across the moon. Like it comes in at different angles and all this stuff. Now on a globe, if you have 3 balls lining up, that should never be the case, meaning it's called a syzygy, which is when 3 celestial objects are all lined up. And in this case, if in terms of adapting that to heliocentrism, you could try to say it's like 3 billiard balls or 3 balls that are lined up. You're going to get a very even phasing from left to right because they're all 3 lining up in a perfect line. There's no other way it can be. It would have to be one direction. However, what we see, if it was 3 balls, it would have to be one direction. However, what we see is this totally varying thing that comes in from the top, from the left, from the right, upside down, all of that. And
not random. Like if
no, I'm not saying it's random, but I'm saying that it doesn't fit. Oh, and then the other thing. Oh, so lastly, sorry. And then Kosho was then, I think, what I thought he was trying to say, I'll steel manning him, was he was then trying to say, well, the reason on the globe that it looks like it's coming up from the bottom or down from the top or whatever is because of the lunar nodes and like the angle at which the sun comes in and different things. But then I clarified to say that is absolutely would not be the case if I'm understanding if that's what he meant. Because like I said, you have a 5-degree tilt between the moon and the sun basically. And that's a very slow thing when it goes from 5 at the highest and then it goes 4, 3, 2. That takes like months and months to be playing out. So when it gets to 0, when the eclipse is going to happen, because they're somewhat more rare, and it also has to be a full moon or a new moon on the nodes as well. But when it gets there, like let's say if 0 is when it's exact, then it would be going like 0.05, 0.04, 0.03, 0.02. And then all throughout that little small range, you're going to have the actual eclipse. So in that little bit between 0.03, 0.01, the actual like tilt of the angle of the moon would not change in any appreciable way whatsoever to cause the dramatic effects where we see that thing coming up from the bottom or from the left, from the right, that darkened thing that comes over the moon.
Okay, let's try one by one. So I'll describe your situation and then you tell me what you would expect to see on the globe model. So like the first example is when the moon's setting. So the moon is getting down to the horizon and the eclipse is starting. So the shadow is increasing while the moon's setting. On the globe model, where would you expect the shadow to be?
Wait, say it again, if you don't mind.
The moon's setting, and the shadow is increasing. The shadow of the Earth on the moon is increasing while the moon's setting. Which part of the moon should the shadow be, according to the globe model?
I mean, it does depend on your position of where you are on the sphere as well.
But if the moon's setting, then
to factor
it's
that
just
in.
getting lower in the sky.
Yeah, the moon's setting vertically. That gives you enough information.
I think I'd even get this question wrong.
Yeah, I mean that's the problem with the shadow being in the wrong place is that it's hard to tell just intuitively where the shadow would be, and usually if you're trying to tell intuitively where it should be, you get the wrong answer.
Because the sun's setting for a different reason than the eclipse is happening. They're two different.
I mean the moon's setting. The moon's.
The moon setting. The moon setting and the eclipse happening are two different movements, and it's hard to separate those in your mind.
Yeah, exactly, and that's where the problem comes from.
Well, here's the thing. Here's the thing, though. So on a globe, though, if it was a globe model with the sun and the moon, and it really was the Earth's shadow that was causing that effect, the thing is that those 3 balls are supposed to be lining up in space. So everybody on Earth who is seeing the eclipse at that time would see, well, depending on what position they are on the Earth, but they're going to see the same generalized effect, with like, whatever phase it's in, where that kind of, there's the dark area and then it kind of turns red and all of that. It's going to look like the same on a globe. It would as well. Would look, and the thing is that it would depend on what position of the globe you're on. Like if you're in the southern hemisphere or the northern hemisphere. So I realize there's that, but the thing is that you have times where, for example, this even debunks it even further. Even whatever angles you want to try to think of on a globe or whatever, that you could try to get some other effect if you know. But the thing about it that really is the clincher to it is that, okay, that darkened thing that comes in, as it were, during the eclipse, not only does it come in and out from different angles, like 45 degree, 80 degree, whatever, not only does it come in and out from different angles, but it actually changes its vector during the time of the eclipse when it's actually happening. So what I mean by that is that sometimes that darkened shadow, maybe it comes in from the lower right, and then it glows red and all that. And then when it exits, the shadow will exit to the upper right. Or sometimes it'll be from the top down is when it'll enter, and then it'll exit going back up to the top. So it's actually doing things that are completely incompatible with the idea that it's three balls lining up in space. Like that actual darkened thing is changing its actual vector in a way that shows that it's not three balls lining up, that there's another, that whatever that darkened thing is, it seems to be on its own cycle, like its own cyclical pattern that has its own vector to it. And that's why it has those effects where it comes, like it literally, like sometimes it does literally a 180, or sometimes it'll come in from the upper left and then it'll leave from the upper right. Every combination, lower right, upper left, all of those, like from the bottom, from the top, from the left, from the right. And then, like I said, it also will even change like the actual degree of direction, sometimes even 180, but other times maybe only like 130 degrees, other times maybe 90 degrees, different amounts as it's actually changing its vector as it phases across whatever that effect is on the moon. So that also shows that it can't be three balls lining up when you get to that detail of it.
Go ahead, Bacon. I don't want to steal your thunder, dude.
Well, like I see Jules using his intuitions to tell whether or not that matches.
He's talking about field rotation now.
Yeah, I never said intuitions either. I'm talking about actual.
No, I know you didn't
direct,
say
observable, astronomical, direct
right,
effect
but
what we observe.
Yeah, but you're determining whether or not that matches three balls aligning, just like picturing that in your head, right? That's what
No, because
I mean by.
You can't have three balls that go from a partial syzygy into a complete syzygy, and then back to a partial syzygy, which is what it would be, a lunar eclipse on a globe Earth model. It's like before the syzygy when it's like a partial, and then into the exact of it, which is when the eclipse would happen, and then after it. And the effects of those three balls lining up, even though you would be on a different position on the globe, that I would agree with, because if you're on the southern hemisphere or the northern, like, yes, that does need to be factored in. And that would explain as to why it might look at a slightly different angle, but it doesn't explain all of these other effects, and it doesn't explain the actual way that it changes its direction, because you can't have three balls lining up in which that thing is actually changing its vector. It would have to be an equal phasing, because that's what the three balls lining up is all three of them coming into alignment during that, unique little few hours.
There's a lot of complex motions that's going on that you're sort of describing, seeing, but sort of it's hard to describe, like how field rotation. Go ahead, Bacon, because there's field rotation occurring. Yeah, go ahead, Bacon.
Yeah, when I said that you're doing that in your head, is exactly that. Like it's a very complex thing to tell whether or not this is compatible with three aligning spheres. So the correct thing to do would be to model then three spheres where they were supposed to be, and then see if within that model what is showing you is the same thing as you're observing. Because if you're just trying to use your head and just think about it to figure out what you should see or not, because it's a very complex thing, it's very easy to get the wrong expectation of what you should see. And that happens all the time. I wouldn't trust myself. I'm not saying that because I don't trust you, Gio. I wouldn't trust myself doing that. Like I wouldn't just try to picture things in my head and say how it should look like just based on that if the situation gets very complex. And in this case, it is very complex. So I would trust something more solid. Like I would try to model that, and if it turns out when you model it, it doesn't match where the shadow would be, or the thing you're describing is actually what should take place and always see, then you definitely have a point there. But I can't just trust that that's the correct thing to expect. I think you might be wrong there, and I'm not sure how to evaluate whether or not you are wrong there. This is a very complex scenario.
All right. Well, I hear you on all that response. What I will say, though, is that I would say perhaps what you shared there are some things that I wasn't really saying myself necessarily. So some of that was like your perception of it. Like, for example, I never said that it was just sort of like a feeling sense or an intuitive or anything like that. I was talking about the actual direct astronomical observations with geometry. So if you have 3 balls and by the time, like before the eclipse happens, okay, let's say if it's a globe model, let's say if it's a globe, you have the globe and then the sun and the moon. In the globe model, the moon's plane of orbit around the globe Earth is at a 5-degree tilt from the ecliptic, which the ecliptic in the globe model is the plane of the path of the Earth around the sun. Would you agree with all that?
Yeah.
Okay. So right before an eclipse happens, within, let's say, the last 24 to 48 hours, you would agree that the moon, the 5-degree tilt of the moon's orbit is now all the way down to almost being at 0, right? So instead of being like a 4-degree or 5 or 3-degree, at this point when the eclipse is about to happen, you would agree that the moon is like, a fraction of being fully aligned with the ecliptic, right?
I don't think the degree is changing, is it? Like what's happening is that there is a point where the path of the, let's say the moon's ecliptic intersects the eclipse of the sun. And that's where the moon's getting close to. But I think the angle is the same, isn't it? Isn't it still 5 degrees?
Here, can you see this right here? Here, I'm gonna post something in the chat. This is a little, it's got a little globe in there. Can you see that?
Hang on. Let's see. Yep. Yeah. So that angle.
Okay. Yeah. So
between
real
those
quick.
two
So okay.
circles.
Yeah. So if you have the globe
Go
Earth
ahead.
or whatever, see how it says over? It says the globe Earth in the middle, and then there's that little 5 degrees thing. That shows. So when these two orbits basically are furthest away from being aligned, it would be that 5 degrees, and then slowly throughout the year, the descending node at the top and the ascending node, those are the two lunar nodes. And when they intersect there, when the gray line intersects with the yellow line, which obviously that's the path of the sun and the moon, when they intersect is when eclipses happen. And when it's a full moon or a new moon and it aligns with those nodes, the point at which they intersect, then you have an actual eclipse, and it's either partial or a total eclipse. So that point where the lunar nodes are, the thing is, see, even if you took this over like a planar stationary type Earth, and it would just be, you could have the sun and the moon, the exact same thing. Instead of that being around a sphere, imagine the gray and the yellow lines of the sun and the moon and the ascending, descending nodes are just directly above us. Kind of like the little like angel rings, when people wear the, like rings above them. It's sort of like 2 rings that are above us, and it still would have this 5 degree tilt and the ascending and descending node, because there's a lot of reasons that I could go into after as to why that does seem to be the case. So, but my point is that when the eclipse happens, it's on the ascending or descending node. And the thing is that like the speed at which the sun and the moon go around those nodes is very slow. It's like once every like 19 years is how long it takes to do a complete cycle. So it's a very slow moving thing. So when the sun and the moon slowly get up there, they're already aligned, very, very close to it. And then right when the eclipse actually happens is when there's that exactitude. So The only thing we would get, the fact that all three of them are lining up, would be one very easy, simple phasing of the shadow from one side of the moon to the other. A direct, because it's a syzygy. It's the three objects lining up, and the nodes are already right there, and then it all lines up. So what I would expect, if the heliocentric model is correct, I would expect that, yes, that you would be looking at the moon from different angles, depending on where you are in the sphere, northern hemisphere, southern, etc. So yeah, you would be looking at different angles. However, what you would be looking at would be the huge moon, essentially, and then the shadow of the Earth, as it were, that will start to overtake the moon. And the fact that that's happening in the globe model is because the three are lining up. Sort of like the moon is finally lined up to where it's going to go, like, essentially kind of behind the Earth at the exact point at which, in their explanation of it, where that's going to occur. So the shadow of the Earth, quote unquote, across the moon would be one even sweep, because you have the three things are all lining up. Those lunar nodes are already right there, so it's already within 0 degrees, and so that's not moving any more than 0.01 little bit as that kind of comes into exactitude. And then you would get, if it was the three balls, you would get this even shadowing thing of the Earth coming in the way, as it were, is what they try to say it is. And it would move from one to the other as the moon is making, because they're all in a plane. The sun, moon, and Earth are all in a plane. Basically, they're in a straight line. And so that straight line can only have that one phasing of the moon that everybody should see from their own angle. Because whether you're looking at it from whatever angle you're looking at it from, should see that same effect. And it would be one even phasing, whereas what we get is that darkened thing is not an even phasing. It changes 90 degrees, changes 120 degrees, changes 180 degrees. It actually changes its entire trajectory across the surface, which is not physics that can work with three balls that are lining up. It's just completely, that doesn't even fit with the geometry of that. You would have to have a third thing that's actually doing a different vector to cause that.
Oh, yeah, I think the best way to check if that's the case would be to get an example, and then see whether or not that does match or it doesn't match.
Yeah, that's fair. That's a good test if to verify it yourself. Yeah. I mean, what I guess I would say, even though I'm stating it very firmly, but I mean, I would still say, I mean, if you were able to show somehow that you could have three balls lining up that would cause a complete second vector of the darkened shadow, quote unquote, to actually add an additional movement of physics and an additional entire vector that isn't present in the geometry of the three balls lining up, and you could somehow show that replicated, then because if that's what you're asserting, then that's what you would have to show. I mean, not that you have to, but I'm saying if you wanted to verify or show that is possible, because
yeah, all I need is just an example you can point at, so I can get the specifics of that example and see if that does match or doesn't match. If it doesn't match, then you definitely have a point there. But so far, what I've simulated, what I've tried to replicate, I did got the right answer. Like, I did got the same thing as it was observed. So very good accuracy, like this totality path.
Well, for that though, that's a little bit of a different thing, because now you have to assume that their maps are correct. Because if it's a path, and it's a path over what? It's a path over a map, and now you're getting into the whole map thing. That whole assumption. And if that's actually, already been, let's say, pre-treated with the globe, then it's going to give you a false positive.
Oh, not really. Not because the map itself was just used to draw it. Like, what matters is the coordinates. And the coordinates are, as we talked about already, not dictated by any map or any organization. Something you can go out there and check that your latitude is, whatever your latitude is, just by seeing star trace, for example, or just getting any celestial body and that is at the celestial equator and see how high it gets, or looking at Polaris. Like, there are many different ways you can figure out your coordinates that is independent of anybody. And what the path is telling you is in which coordinates you should see a a totality in the eclipse, and at what time. And that's what people use. Like when you want to know where to go, you go to the totality path and get the coordinates, see where that is. That's gonna match a city or a certain place, and you can go to that place like it's a real location. And that's what people that took, yeah.
No, I
the
agree.
map. I mean, even if the map is distorted and distances are wrong, I'm still getting the coordinates directly, not exactly. Like I didn't get the coordinates from the map. I just got the coordinates directly, and then I plot it on the map. So if the Earth is a different shape, that would just affect how I'm plotting it, but the coordinates would still be the same.
Right. Yeah, that basically summarizes it right there, dude. You just said it. The coordinates are the same, different how you plot it. Yeah, well said. Yep. Which model you plot it, you can plot it on different models. That's what I'm saying, dude. There's like an overlapping factor between these different models and ideas, between spheres and planes and all of that, in terms of how, the right order of things, as it were, when it comes to physics and when it comes to some of these core geometries. And there is
Just to clarify
overlap
one thing.
in the geometric transforms, which is how they've been able to do this, and to how it seems like it could be valid upon initial considerations.
Yeah, well, yeah, just one thing. I said it would just be a different plotting. I didn't use the globe to plot the coordinates.
Well, you said
I
that. You said that, so I was just repeating it. But we'd have to get into more what you meant by it. But I just thought it was a good.
I said the map. Like I used the map to plot the coordinates. I got the coordinates from the globe, and then I plot on the map. So, all that would change if the map could be wrong, but if I would distort the map so it was right, the cities where the path was over would still be the same cities and still be the same time. It would just change the shape of the map or the positions on the map, but the whole prediction would still remain. And the way I got the coordinates was using the globe. I didn't put them on the globe after I get them. Just clarifying that.
Yeah, it's just replacing the celestial sphere with a globe based on assuming that the lights are very far away instead of close and local. I mean, to really break it down super simply to the base level of it. And then how are you deciphering between those would be the key to it in terms of getting to the truth of it, whatever the case, in terms of the differences of those and how that's actually mapped to the actual ground and validating that the ground actually has that shape to it over those long distances. You know what? It also, have you ever heard the phrase, Bacon? The map is not the territory.
No,
have you ever heard that?
But I can get. I think I get what it means.
Yeah, it's sort of like there's a lot of different ways to see it, but let's say this: if you have a flat screen TV, like okay, if you this'll I just got it. Okay, take like a GoPro camera, put it right up to a basketball, and move it all around. All right. Mm-hmm. So now just imagine you have a bunch of video footage of a GoPro going around a ball. Then take that footage and upload it to a flat screen TV, one that's very flat. You can actually navigate using the GoPro camera footage. You could navigate around the ball even though you're looking at it on a flat screen, and vice versa. So that's just part of how this is done. That's not the entire part of it, but it's a geometric transform. Like you can still navigate around a sphere that is mapped on or that's being projected to you on a flat screen TV. So
yeah.
So there's transforms, and when it gets to deciphering between these models, getting into that 8 inches per mile squared, that's where you would need to be able to have some way within what you're doing to decipher whether that 8 inches per mile squared is actually on the ground or not, even if you can be given certain models and maps that work with the sky. Because they can map, you can have a flat planar surface that could be mapped within a fabricated spherical geometric system. Of course, they're not going to be exactly the same. There will be differences, but that would be where essentially they would have to do some level of cover up, like with GPS and with a few things, to be able to pull that off. But the question is, to what degree can that be done? And with the 8 inches per mile squared and with that amount, I think it's within the range of what they've been able to, what they're able to do with that. And on the side you're coming from, you're using certain assumptions that you think are a prediction, but from what you said, unless you have a different, or whatever if it's different from what I would perceive what you were saying, but like you're using certain assumptions and then plugging those into the model, but then you're not actually able to verify like the actual 8 inches per mile square to verify that part of it is actually there, in which the model, in which is what you would need to really validate that model actually matches with physical reality, and it's not just a correlative model based on reverse engineering that can still calculate correctly but not necessarily be depicting reality. Which is why I said like the idea of the map is not the territory. Like you can have certain kinds of mapping that can even work to a certain degree and can even help you navigate, even though it isn't the actual territory, but there can be certain overlap.
Well, I mean, if this was interchangeable, like there shouldn't be that hard to do something similar from a flat Earth point of view, like
To break the tie to see which one's different. Yeah, I agree. I mean, well, if you can devise something, dude, we're going to be doing it for the next decades. We're just getting started. I mean, if you have a way to help, yeah, I mean, that's what we need to do, dude. We need to show actual, like, not just models and assumptions and ideas. I mean, that's all interesting, and I'm not even putting any of that down. I think all those things are interesting exercises and considerations to think about. But we need, yeah, I mean, to really get a direct answer, I would imagine you would even agree that we would, we really would want something more.
right.
Would you agree with that? That you would want something that's more tangible than what you currently have?
Oh, if there was something more tangible, that would be better. Yeah. I mean, what I did was not that big of a deal, I think. The thing is, I can do countless examples of this.
Well, you know how like
And
on Stellarium,
yeah,
you can switch back and forth between the azimuthal grid and the equatorial grid. And the azimuthal grid basically has kind of a planar foundation, and then it's surrounded by essentially like a hemispherical sort of dome, as it were, of stars, and it maps it that way. And then you can just click the button and it goes over to equatorial grid, and the equatorial has the Earth as a sphere, and then all of the stars and all of the things are in a celestial sphere that's like projected 360 degrees in all directions. And you can even kind of look through the Earth and you can see like the celestial sphere on the other side of the Earth or whatever. So between those two models, the equatorial grid, which is the one that the name that they use for the globe one, in that sense, which is surrounded by all the stars light years away kind of idea, or just in a huge sphere around you. And then the azimuthal grid, which is where it's a kind of a flat planar circle, and then you see the hemisphere above you. And those two are transferable. You can just click right back between them. And then, of course, a planetarium that shows kind of a hemispherical dome as well, the way planetariums work. You have all of that. Now, the difference is, though, obviously that those are going to map different, though. Like a planar surface versus a curved surface is obviously going to have some differences. And this is where I think you would have interest in terms of with the celestial navigation, because there is a way to decipher between them, even using celestial navigation. And there's other ways to do it as well. But unless you can say you actually have tangible validation of it, I would imagine you would then just have to admit that you are going off certain assumptions and beliefs without having like knowing 100%.
I missed the punchline.
Unless, I mean, do you feel like you have that now, or are you going off the assumptions and then, you know what I'm saying? Because you're saying that you think you have the prediction because the model and the map of the Earth you're given, the way that the eclipse, is modeled in their system would fit with the patch of Earth that it went over, right?
Yeah, I think that helps validate that this model is accurate within the extent of the prediction. Like, you can see a better way to validate a model than try to see what you should expect if that model was correct, and then see if that's what we observe.
Well, so if you took a planar surface and then you have observers on it that are all seeing in like a hemispherical range around them, and then you have them on a massive planar surface, would you agree that you could take that matrix of reality with that kind of hemispherical dome of their how far they can see and the optics and perspective and all of that, that people on that planar surface could reverse engineer it to use those optics and the actual geometries of that to reverse engineer a model in which the Earth itself is that sphere rather than the actual sphere that we see in? And then reverse the math and then get to a point now to where they could pull that off?
I don't think that would work. Like if you have, for example, if you have a dome over.
That's what they've done.
Well, don't think that would work. Like if you have a dome, have people on a flat Earth that is inside of that dome, where the stars are, for example. The part of the dome that is closer, like that dome is local compared to the Earth. Like on a globe, the stars are like billions of miles or trillions of miles, and on the dome, it's just like a couple thousand miles, right? Because that's the extent of the Earth. And if that's the case, then the people that are in the closer part of the dome, compared to the people that are further from that part of the dome, would see stars that are further from each other if they're closer, and the people that are away from it we should see those stars closer to each other. Like the angle between those stars should increase or decrease depending on how far they are from that piece of the dome. But it turns out that the angle between stars is the same for every observer and every time. That's not something that is changing with time or with location on Earth. So if you create a dome and try to reverse engineer a sphere that has stars infinitely far away, that sphere, that model would fail to predict how far apart the stars are to begin. That's already a failed prediction you'd expect on a scenario like that. And that's not what happens on the globe. Like the predictions on the globe are very accurate. And they also predict that the angle between the stars is the same, is constant. Which is what we observe. So you have to add optics that can allow that on a flat Earth. I mean, but then you're going to complicate things a lot. And I'm not sure you have the physical means of having something like that kind of optics even possible. Like that's why stuff like Walter Benson model looks so complex. It has those very weird light bending rays. It's trying to show how complex optics will have to be, or the observation we have now to be allowed on flat Earth. I mean, it might be possible, but We have no mechanisms that they come close to that.
Well, I would say it's just the foundations of how we've mapped the sky and how humans have observed reality since the dawn of time. Meaning that if you have like whatever the Earth actually is beyond what we can see, or the sky, I should say, whatever's, in terms of how far away those may or may not be or what exactly they are, even outside of that, if we see let's just use that 4,000 miles for the moment, that would give a diameter of 8,000. Now, I'm not saying that is or isn't how far we can see, but if you have 8,000 miles on like a 24,901 circumference, like a planar surface, like with the North Pole at the center and the continents all coming out from the center, kind of like the AE map, etc. And if you could see, let's say in about an 8,000 mile, then that's like, let's say, roughly a third of that whole thing in a sense. Now that would change obviously throughout the seasons or throughout the different time and so on. Now, whatever the Earth is, like whatever the sky is beyond that, each person's like, let's just say in this just example I'm using, and I'm not saying it is or isn't this. Like I said, I'm just throwing numbers out, like an 8,000 diameter range. Then that's like the section of the sky that they can see, depending on the season, the time of year, the conditions, all of that. And that's as much as any one of them will ever be able to see. You just can't even see beyond that. Like, so that you can't just see 10,000, 20, 80. It's just not a thing in this kind of way of seeing it to where each person can only see that. Let's just say in this case, like I said, 8,000 miles diameter range. And then whatever the like larger thing is above that, whether it's even higher or whether it's like whether there's a huge dome above us, like whether the actual sky is slightly curved or whether it's just like a flat plane of stars, whatever all the, in terms of all of that, just in that 8,000 mile diameter region that we're in, we would see a rising and setting of the sky, sun, the moon, the stars, etc. in that particular location, only seeing one part of it. And when you then link like a sundial, what sundials do, and moon dials, and then the zodiac and all of these different geometries, I would say like for you to say that it can't work on a quote unquote flat earth, if that's what you were saying, or you're just saying I would just completely disagree and say that it already has been doing this since the dawn of time. And that's why humanity, I mean, even going back to the original, like the sphere was something that had to be added later because they already had all of like, plane geometry. But anyways, without getting into a whole discussion on the ancients, but yeah, there's a lot, of course, to all of that as well. But the thing is, I don't think that you have the correct map, and neither do I right now. So when you say it doesn't work on a quote unquote flat earth, I just hear basically you're saying we don't have the correct flat earth. Like you just don't have the correct thing yet. So you're going off of models that are partial and that are not actually correct. And that's part of the issue. And then you're being given a lot of the globe stuff, I would think as well, going over a lot of that stuff that they're given.
Well, the reason why I said there's a problem with flat earth there that I can't reconcile. I mean, maybe it can be reconciled, but I can't reconcile. Is this angle between stars being the same for everybody, all times, and that does not rely on any specific map. Any flat Earth map, any distribution of coordinates on the flat surface that has stars that are local, you shouldn't expect the angle between those stars to be the same for everybody. If they're different distances to those stars, then the angles should be different. I see no mechanism that would allow those angles to be the same for everybody all the times on a flat Earth with local stars. And that could be the case with very far away stars, but then I don't see how people could have different skies like this. If we have stars that are so far that the angle is the same for everybody on flat Earth, then also everybody would have the same sky on flat Earth. I can't see any different way that could happen. And that's not relying on any
the thing
particular
about
map.
that, okay, look, when I was saying the 8,000 mile diameter, like that we see in that, when I was just throwing that number out there, imagine that also goes up as well. So in that kind of idea, let's just say, so that would be like 4,000, because it's an 8,000 diameter in that example. So it'd be like a 4,000, which is of course what they claim the radius of the globe Earth is. But if it was like 4,000, you know what that would mean? That would mean that, let's say you can see in a 4,000 radius hemisphere, just in this example, that would mean that everything that, no matter what the sky is, no matter whether it's planar or curved, whatever it is, you would see only that 4,000. So meaning that whenever those stars and those things came into your region, they're going to look like they're rising in your 4,000 mile radius hemisphere. And they're literally going to just look like they're rising. They're going to go right above you. You can be pointing to it the whole time. And then it's going to hit the zenith at the peak. And then of course they're going to start to set. You can point at them as well. As you did that, if you were pointing at it the whole time from sunrise to sunset, you would have been pointing horizontal, and then you would have gone all the way up slowly to vertical, and then back all the way to horizontal. And you'd be making your own little hemispherical dome with your finger basically through the air as you're kind of doing that. And then that would relate to how far you can see. So everything in your local region would then be rising and setting within that hemispherical region. I would say that even on a globe Earth, it would actually be the same way. Technically, there just would be curvature, but it actually would be the same. Although I know on the globe thing, they try to say we can see light years, and there's a whole different kind of model of how we see, I guess, which is what they've had to do to invert the models.
Oh, I don't see how you could invert it. Like, I'm not sure how what you're saying would address these problems that I'm seeing on just being an inverted model. Like I still would expect stars to be, the angle between pairs of stars to be different for different observers on the flat Earth, or the same sky for everybody on flat Earth. But not both of those the same at the same time on flat Earth. I can't see any mechanism that would allow that.
Well, that's what I'm saying. If you're seeing in what I was laying out in that 4,000 mile, then it's not going to appear to you the same way that, like, if you were in a, like, okay, I would say this: if you're in like a warehouse, like a huge warehouse, and there's a bunch of lights that are just like 50 feet above you, as those lights move away from you, that's what you're talking about, right? Like the parallax angle between them. Is that what you're talking
Yeah,
about?
something like that. Yeah. Yeah. Perspective. If there's a pair of stars close to you and you're further, that distance between them appear to shrink. They're further from them.
Right.
And
Okay, so I know I've probably shared this with you, but if you want to kind of consider this, where, okay, if you take like a dish pan and you put some water in it, just like about an inch of water, whatever, and then you put a little dish soap in there and then kind of swish it around, you can get a bunch of bubbles, and you can even get some kind of larger bubbles, like ones that are like decent size. So now you have these bubbles that are basically like creating like a hemispherical dome on the water, the water level, and then you have these little hemispherical dome things. If you then take like a flashlight or like a little pen light, and you start moving it above, like let's say you have a bubble that's about an inch or maybe 1 or 2 inches in size. So it's like a decent little bubble there. If you then take your pen light and you start moving it around, maybe 12 inches above the bubble, so now you're up quite a bit, and then you circle it around and around, the reflection of that pen light will be displayed right on the bubble. And then even though you're moving it up and you're doing all this other, you're moving it way up above it, it actually shows to that bubble that it's like just rising and setting at exactly the radius of that bubble. So I'm not saying that there's a bubble around us when we see. I'm not trying to say we see in some magical bubble, but I am saying that, like, if we have a limit to what we can see, then it's going to act in a similar way to that. So do you see what I'm saying? That like now that's a little bit of an added idea, because now we're talking about like a reflection on a surface. So I realize that's talking about like an additional thing, or like even speculation, like is that what the sun is and so on. But I'm just just using that as one example where if you see in a limited range around you, then everything that comes in and out of your range is going to be like equally spaced within your range of what you can see. And I don't think it's analogous to try to claim that, you know, the dramatic angle changes that happen from lights or whatever, or like street lights as you're moving away from them, would happen with stars because it's a completely different scale. And but I do see why you're bringing that up. But
Right. Yeah, well, I need to know how the scale changes it to see what I should expect on that model, on that idea, and see if that matches reality. I mean, that's the whole thing. I just need some way to get a prediction. If I can't tell you what I should expect on that model, then I can't validate it. That's my problem with Flutter so far, is that whenever I do, they don't match, and people say, no, that's not how Flat Earth is. It's more complex than that. But then I also don't get a way to draw predictions. I can't tell you what I should expect.
Oh, well,
It's
it
like I did with
depends.
the eclipse.
I mean, with the azimuthal equidistant, you can know exactly where that eclipse is going to appear at a point
Oh,
on
hang
Earth's
on a second.
surface. Okay.
oh, you were making a good point there too. He said he'll be back in a second, but
Yeah, that's what the azimuthal equidistant is for, right? To observe the celestial sphere from Earth's surface. So you can find the coordinate system. The GPS is based on basically longitude and latitude, but it's actually circle of latitude. Well, I'm sure you guys are all aware of that. Flat earthers.
Sorry, I I stepped away. If you were saying that to me, we're gonna have to repeat
No,
that.
no, I was just saying how the azimuthal equidistant is good for celestial observations, so you can pretty much pinpoint the location where it's probably most likely going to appear on Earth. Like, so you,
Oh,
like it relates to your, azimuthal coordinates,
I
horizontal
mean
coordinates.
the azimuthal. I mean the projection, the map.
Yeah, you can tell.
Can I get an example of that?
Yeah, sure. I'm gonna send you a picture. I actually made one. I actually made one because I didn't see, I didn't find any, but that's pretty much how it's done.
Nice.
All right, here it is. So yeah, basically, I was testing a whole bunch of GPS coordinates from like Google, and like they all match up with where everything's supposed to be. And then from that point, you can basically get with the time and date, you can get an accurate prediction.
Right. What exactly are we predicting? Just so I understand what you're saying.
Well, if you want to see the eclipse, right?
Yeah, the eclipse.
Okay, so by knowing where it's going to be in the sky, you can pinpoint the location on Earth or you're most likely to
Yeah. So
observe.
let me.
Yeah.
I'll drop the information that should be necessary to
Okay.
do that.
I can get, like I said, I just found it accurate for longitude and latitude. I didn't know that they actually use circles of latitude. So it's like impossible on the globe. But then again, I feel redundant when I'm saying these things because it's been such a, that map has been out forever, you know?
What is not possible on the globe?
What's
Circles
that?
of what? Sorry, you said
Circles of latitude? Circles of latitude. So, yeah, the cross section equator, and then the Tropic of Capricorn, and then the equator, you know, the Arctic circles and all that. Yeah, basically. So, yeah, those are the circles of latitude. And they're like
about that
they're concentric circles. They're basically like a whole bunch of concentric circles that go all the way to the center of the Earth.
Yeah, why isn't that possible on the globe? I don't get it. What about that is not possible on the globe?
Because for one, if you trace the Tropic of Capricorn on Earth's surface, the circle is actually wider, like more elongated, like it's wider. So like it's a bigger circle. Anyways, on the globe, it's not. Right.
The Tropic of Capricorn, you said it, or the Cancer? Which one you think is
Yeah,
larger?
well, there's Tropic of Capricorn. Yeah.
Oh, I thought you said Cancer.
No.
Right.
Yeah. I mean, yeah.
So yeah. Well, how you determine that?
By observing the sun directly overhead, like on your zenith, basically,
Yeah.
where there's basically no
Yeah.
shadows. Yeah.
Elaborate
so
a little bit more.
Okay, so you do that, right, around the world, and it does a wider, like the circle ends up being wider than that of Cancer.
How
It's
are
surface
you?
related because
How
it's
you?
based off local observations of the sun.
Yeah. Can
Oh,
I see
okay.
how you're
Wow,
getting how wide the circle is?
that's interesting. I'm happy you're
You see the
challenging
thing
me
I
with that.
post.
Yeah.
You see the thing I post in chat. That's all the information I think
Okay,
we need.
that's yeah. So I'd have to get a location and then relate it to this, right? Most likely.
Or if you want, that we can do just the one data point. I'll give you the exact position of the moon and the sun on the ground, and show me how to get the position of the eclipse for that moment.
Well,
Does
I
that
mean,
sound fair?
yeah, but basically, I'm just saying that it's accurate for your location on Earth's surface, like so.
What do you mean?
I'm not quite sure how I'm gonna relate your right ascension and declination with
Oh,
the
no
map
problem.
projecting, right?
I'll turn that into uh, latitude and longitude. All right. Yeah, I'll use the values for exactly 6 o'clock, 6 p.m. UTC time.
Yeah, because I heard most GPS use the equatorial coordinate system, which
Use ECF coordinate system.
equatorial coordinate system.
Oh, ECF, Earth centered, Earth fixed. What
Okay.
GPS uses.
I guess I'm just being. Yeah, exactly. It includes that.
Hey,
Here, I'll
I
link it to you. I'll link it to you in chat.
don't mean to
I
interrupt
post
you guys,
the.
but I'm wondering if Geo's there. Are you still around, Geo?
Yeah, I'm still here.
Hey, what's up, dude? Hey, earlier you were talking about kind of how the eclipse happened, and I was in a place where I seen the full eclipse. They called it what, the Ring of Fire or something. And I try to find videos that kind of showed what I saw, but I couldn't really find anything that did it justice because it was amazing. It was literally, I mean, I didn't do any measurements, but from what I could discern, I seen pretty much a perfect eclipse. Now, as it was developing, it didn't happen right away. Obviously, it takes, it took like, I don't know, an hour or so from like the start of it. But when it actually, and I was trying to use my phone to film it, and the filters weren't working, and I just, I gave up on that and just looked at the actual eclipse. Now, what you were actually talking about is what I actually saw is as the I don't know, like what you said, the black thing, but that would be the shadow, right? As the shadow um uh made its way to the center, it didn't it didn't just move in place. Like it I hate to say it, but like it like it like moved like in a weird way. Like not at the angle I was expecting. Like I guess you could call it, I don't know, the vector it was once traveling in. It kind of like moved and then it like stopped and then it like went the other way. It was weird. It was just, it was a weird thing that I seen. My dad seen it too. He's like, "What the hell?" Because I was like, "Look, Dad, check this out." But can you speak on that? Like what actually happened? Like just one more time, because couldn't really understand it, but you kind of made good sense of it.
Well, these guys were they were talking about something, so I don't know if they were gonna, because I think Bacon and Neophyte, because I was talking about this earlier and I went in a lot of detail. I don't know if
I mean,
I could repeat it or go into it again, but I just posted an image there. It's kind of a cool. That one shows where you see the same face of the moon, and you can see that's at least one. Where you see the darkened part comes in from the bottom, and then it literally changes its entire vector. It's like it sweeps up from the bottom, goes up to the top, off to the left, and then it like it's you can almost tell that thing is on its own like rotational direction as it's coming across like that actual darken. That's just one example, but that does show.
Do you have one of the sun?
So it's like that's not the effect of three balls lining up. Yeah, it actually changes its own vector and has its own entire pathway as it's making that effect, rather than if you have three balls lining up, one ball, it's like they're getting to exact to where they're all exactly in a line. So you would expect just one process to occur of like right when it comes into intersection. In their model, it's the shadow of the Earth or whatever. So you would get like it would overtake one side of the moon and then it would exit the other side of the moon. But you can see on that little GIF there, on that little animation, like the actual face of the moon is the same. That's not actually changing. So this is not just seeing it from upside down or something like that. You're seeing that exact effect on the same face, the same features, as that moves across it like that.
Right, because look, like okay, from the picture's point of view, we could say that the bottom that it came in at is 90 would be the bottom, right? Let's just make 90 the bottom. So, and a little bit to the left. Man, that's wild. And look where it ends. It ends like right there at the like 245 position. Starts at like on a clock would be like 640, and ends, look, right there at like 245. Like, how is that possible? Like, wouldn't it leave at the same place where it came in from, right?
Yeah, if it was three balls lining up, yeah, because it's making a 180-degree pass across the moon. Yeah, so you would expect an even shadowing to occur that would start on one side and then it would just exit. It would just be one straight shot, because that's what
one path, right? Like,
right. It's because supposed to be three balls lining up. So yeah, it would be one path. Yeah, and it would be the same for everyone as well. And that path would make the same like across whatever you call the features of the moon. Like if you're gonna you want to name this what they call craters or whatever, if you were to map that like the coordinates, if it was three balls lining up, the effect of that shadow, if they're going to say that's supposed to be the globe, would, because it's three balls lining up, it would exactly enter from a in this case like a sideways position. So it'd be like it would be coming from like, well, it depends. If you were like right at the equator and you're looking straight, you know what I mean? Because you can't, if you're up at a different angle, then there is going to be the different angle on the globe that you would see it at. But if you were at the equator, then it would be like directly from the left. or from the the one side. I'm saying either the left or the right, depending on whether you're looking north or south. If you're on the equator, northern or the southern hemisphere, but it would be coming in from one side and exiting to the other, and it would be like the features on the moon. The Terminator line would be an exact an exact equal passing from one side to the other. But like I said, even on that little animation there, that one does show where that darkness, it completely changes its vector. Like it sweeps in from one and changes from another. So yeah, that's what I'm saying is completely incompatible with the idea of three balls lining up.
And it's kind of also what they talk about the motions of like like on a geocentric Earth or like a flat depiction of the solar system. They kind of do like curlicues. What do you call that? Like retrograde and something like that. Is that what that is? Like when they change direction. But in their model they don't. But like on a geocentric like map, they call it. I don't know the term. There is a term though. Does retrograde have anything to do with its spinning or its path?
Retrograde has to do with the planets.
With the what?
Planets.
Yeah, we know that, but does it have anything to do with rotation or just its path? Like a change of path, like a change of direction, right? Yeah, never mind. It doesn't matter. It's not a big deal.
Well, I mean, we could get into that. I think I don't know, Neophyte and Bacon, were you guys still going on that?
Well,
Because
he wants predictions, and I'll admit I can only do GPS coordinates with that map right now, so I don't know how I'm gonna relate that to the celestial sphere, but it should be easy because I already have like a path for it. But yeah, so basically I can't like satisfy his
Well, you
needs.
said that works. I'm trying to understand.
Yeah, it should be able to. Like I told you that every slice is a slice of the celestial meridian, so basically like the sky or whatever. But yeah, I still got work to do. I mean, I was just mentioning that, but yeah, it's a pretty cool map. Like they use it a lot. It's useful.
It's Bacon's kryptonite. He's right now as we speak. He's like, oh, the flat Earth. Yeah, that's funny, Jimmy.
You think you?
Well, Bacon is ahead of his time. He even had a flat Earth birthday party, so he's a millennium man ahead of his time.
Yep. So yeah, Neo.
Yeah.
Whatever the rest of that is.
Yeah.
You think you can get like this totality path using a azimuthal map?
Repeat that. A what path?
A totality path, like the path of the solar eclipse, where it's seen as total.
Sure, because the nodes are like points in the sky. So if you like track the nodes, then you'll be able to predict the sky exactly where it's going to be relative to your azimuthal position.
Oh, one thing is just figure out if the moon would be in front of the sun given a certain coordinate. That I think would be easier to if you're going with that. But I'm trying to go do the other way around, given where they are, their ground position, their geographical position, where that place is. So end up with the position, not starting with the position and verifying if that's the correct one. Because then you'd have to verify thousands and thousands of positions until you found the correct position. That would be.
Yeah, no, there's got to be a way to
Yeah, that's the thing
definitely
that
related. Yeah, no, I got more work to do, but that map definitely has potential. I'll try to make it shine, I guess.
Sure.
Okay.
Yeah, let me know when you have something.
Okay. You want to talk about retrograde? Or what?
Well, you guys can talk about retrograde. I'm being called to another VC. I'll take a look at what's going on there. So you guys have a good night.
Later. I let Flat Earth down, guys. I was underprepared. But I feel like I bring something new, right? I never seen, if you will, like the world compass around the Great Plain, and it works fine.
Yeah, there's a lot more to know and explore. That's for sure. Just opens the doors to so many things.
Well, it's the end all be all, right? If longitude, latitude works perfectly on a great circle plane, the fundamental plane is like the equatorial plane. It's like written everywhere, So
Exactly. Elevation angles to the stars, to Polaris, to the sun and the moon. Yep. Yeah, I mean, it's been mapped in a planar system like that since the dawn of time. I've always said this. I mean, when they first started doing celestial navigation, even as early as like they used to make them with like a coconut, you could take like a coconut, you can pop holes in it, and then you can look through it to get angles to stars. And if the Earth was a sphere, they would have known very quickly, because as you're doing angles to stars and measuring distances and mapping those to the ground, you would have, let's say, you would, I mean, ultimately, on the most simple level, you would have like if you have a flat table or a surface of some sort, even if it was more, even if one wants to consider it primitive, you could just shave down a flat section of like stone, and then you could have some kind of a material that you would be mapping. And if you're mapping all those distances and angles to the stars, they literally would not fit on a flat surface, like on a planar sort of surface map, basically. You would have to actually put that map onto a sphere in order to even map, your results, to even make a map. So they would have known, like they would have been able to see that discrepancy from the very beginning, and it just always would have been known to be a sphere from the very beginning. That's how that basic geometry would have all mapped out if it was. But instead, it's been planar since the dawn of time. They've used specifically having that be, and then the globe has come in and sort of ad hoc, added on the claim of the globe, and then tried to kind of commandeer these angles and try to fit them into a different model.
Well, yeah, see, I agree, like you said, but it's kind of a sphere because the sun follows like perfect curvature of like a dome. So it's, it kind of alludes to being a sphere, right? But yeah,
The way things kind of look hemispherical around you, you mean?
yeah, exactly. So basically, yeah, like the curvature is like 3D, It's about topology and all that. It's not really about like the hard Earth itself, That's just. But yeah, you made me think of that when you were talking. You talked about tracking. Like I can use the planisphere, right? We got that. So if I get the coordinates of some place and with a planisphere, I can predict, dude. So that's really cool. I'm actually gonna write that down. Thanks, man.
Yeah, exactly. And planispheres are basically, if you're referring to like the star chart usage of the term planisphere, it's like a flat disk essentially that you can kind of spin, and then it shows you the position within essentially the azimuthal grid. Yeah.
Yeah, exactly. So that's perfect. All right, cool. I have some work to do like tomorrow. Yeah. All right. On that note, I'm gonna leave you guys. That was fun. It's my first time being here in like forever. Cool spot.
Yeah, for sure.
All
Bro.
right. Good night, fellas.
Yeah, you too. Cheers. See, Kosho, we could have a big thing where you get teams out there all doing their celestial navigation. They have to match it up. And then maybe once they reach their conclusions, the teams have to swap all data and go double check each other's data to see who was right. That'd be huge.
You gotta say teams and dudes, and then you would have had them.
Well, we could make that happen. It seems like there tend to be more men interested in the rigorous testing of the earth. It seems, in a sense, women are more kind of in a flow with it. Men seem to be more wanting to measure but not at all. I mean, that's just generalization, obviously, but yeah, I don't think Kosho he didn't bite.
Hey, Gio. How you doing, man?
Yo, what's up, Kenny?
Good to see you. Always good to see you, brother.
Yeah, you too. What's the latest?
You know, there's an AI glober bot. And we were putting it through the test today over on TOS UK, whatever. And just kept asking it questions like, hey, man, where's the curvature? And yeah, and is literally like talking to a glober. It was hilarious, man. I hadn't seen anything that funny in flat Earth in a long time, man. But so be careful for the AI glober bots, man. That's all I'm saying.
Dude, are they gonna unleash them?
Yeah, they're gonna unleash them. Mm-hmm. So be careful, man. Be careful. Kosho, man, you got some competition coming, man. Be careful.
Yeah, well, there was I think Kosho brought one of those on here once, or he had a Chat GPT or it was a couple.
Yeah.
And but there was one other one that he was doing too, and it was responding to globe questions, and basically Jeremy got it to contradict itself within the first like 5 minutes.
Yeah,
2 minutes.
Yeah, it was like 2 minutes, right? Yeah, this thing was fucking up too, man. Today, I was like, I'd never heard because it has a voice, and it would respond, and it was like it would just give the same responses that the Globers would give, man. It was like, come on, really? I mean, it's pretty weak. I think it. Any one of us could probably trick it at any moment, but just asking it like a simple question, like, where is the actual horizon? Is it geometric or is it apparent? And it'll just cuck out. The damn thing will just cuck.
If
I
you
just
ever
know
want
it.
answers, you can always just ask me. I'd be more than happy to provide you those answers at any time.
The Xanac AI.
Yeah, we need a Xanac AI, man. That's what we need.
Hold on a second.
Xanac and Kosho together, that would make a pretty good globe AI, man, for sure.
Xanac, I sent you a DM. Hold on, real quick. Xanac, I sent you a DM. You never responded. Why?
I think I did respond.
How many
I
degrees
always
out of
respond to
position
you.
is Polaris when it's at 45 degrees? You didn't
What's the
answer
I
that.
question?
said it'd be near exact. Yeah, I said it'd be near exact. I mean, there'd be some dithering due to any kind of refraction that would affect light as it traversed any atmosphere, any
Yeah, so how many
molecules.
fractions of a degree would we be seeing it out of its
I wouldn't
actual
be able to
position?
answer it exactly. It really depend on
Well,
the
of
evening
course you
and
couldn't.
the day.
It's
Or the evening.
ridiculous. Yeah,
Has to
there's
be
no refraction at 45 degrees, man.
no, right. There's none, but there's always something. The air. The fact that you're running light through air, there's always an angle of
Well,
incidence with. I would think
that's why we see the stars sparkle according
Yeah.
to, right?
Yes, exactly. And that is a very very small change in not really position. I mean, it's if you had a way to measure the center point of a star and see what that twinkling was doing, it might by some minute amount move around, but it's not really. It's not what he's talking about. I don't know why you want that answer, but I don't have the answer from me is I don't have the answer for you.
Fair enough.
We'll add it to the list, Zanuck.
Yeah.
Oh, it's
Well,
fine. I'll just ask the AI, and then it'll give me an answer, and then.
Oh, the AI had the answer of refraction on the horizon. If the sun rises, you really are not seeing the sun because it's actually behind the horizon, and light refracts above. And that's what AI was doing today. And I was like, really?
Yeah, it's not the actual sun because it's a refracted position, but it is the actual sun because hey, that's the curve of the Earth that it's coming up around.
Yeah, it was a bit hilarious, but that's the actual AI gave that answer, man. It gave it. I was like, damn. Shit, we don't need Globers. We don't need you, Zanuck or Koso. We don't need you guys anymore. We got AI. Fuck. You guys are done. You're being replaced, man. You're being
That would hurt if that
replaced.
was true. That would hurt a lot if it was true.
I got a
You
question.
need me on that wall. You want me on that wall.
So I've been looking at the GIF that Geo posted, and I've been trying to figure out in GIMP how to do this, but my GIMP foo is not very good. The shadow cast on the moon looks like it traces out the outline of a larger circle. Does anybody know how to trace that out and see if that's the case?
You're talking about a lunar eclipse?
Yeah, the one that Geo posted. The shadow cast on the moon seems to make a larger circle.
What was the post? How long ago?
It was at 9:32 my time. It's 9:54, so that would be like 20 minutes ago. Yeah, the last post, mine links to it.
I'm looking.
Yeah, I was trying to play with GIMP to trace it out and make sure that what I'm seeing is there, but me and video editing software aren't exactly the best.
Yeah, I hate video editing software.
Yeah. But someone at some point posted a picture of a bunch of moon phases put together and how it traces out the silhouette of the Earth cast upon the moon or something like that. That's what made me think about it for this one. So
you're talking about the analema or something different?
I don't know, but basically, if what might help me see these things is I have in Discord I have it set so that moving GIFs and such don't automatically play. They only play when my mouse is hovering over them.
Yeah.
So sometimes I see things in GIFs that other people don't necessarily see because of that.
Okay.
Fair
enough.
I'm wondering if the shifting movement that they were talking about earlier is just the fact that it's the edge of a larger circle or something, which would not explain the ring of fire and the movements that they were talking about for the actual solar eclipse. It would only be for this lunar eclipse.
The one that was like a week and a half ago? No.
I'll link to Geo's thing again. Oh, the eclipse. Yeah, I'm assuming that's what they were talking
I mean,
about. I don't actually know.
we had a solar eclipse and a lunar eclipse within a week. I don't know, you guys saw.
Well, someone earlier was talking about seeing the Ring of Fire, and you only get that with solar eclipses.
Yeah, well, that's if you're only within like a 70-mile radius of above the sun. Yeah, you'll see the Ring of Fire.
Yeah, I think it was Good White Light who was saying that they saw the Ring of Fire, and they saw unusual movement in the shadow upon the sun as it was traversing or something. And then Geo posted this GIF as kind of an example of what that might be like. So I was just kind of looking at it to see if I could figure out the motion, if it was like the result of the Earth spinning, because there's more than just, a two-dimensional plane of movement. There's a lot of three-dimensional work there. But looking at this GIF, I saw something that might be a lot simpler. Just the shape of the edge of the Earth being traced on the moon as it goes through the eclipse.
Oh, that's cute. Earth has an edge, huh? I like that one.
What now?
You said edge of the Earth?
Yeah, it looks like it as the moon goes through
The
the
leading
image.
edge. We call it the leading edge.
Okay.
Right?
I didn't know spheres have edges. But
Yeah,
go ahead and expound on them.
Well, a spherical object can have an edge. We all get that, man. It's the outer line of the circle. I mean, that's the edge, right?
Yeah, what I'm saying here is the shadow cast by the Earth on the moon seems to trace out. Yeah, you get what I'm saying, right?
Oh, yeah, of course, man. And that's certainly been in contention for.
Well, no, I mean to Good White Light, because he was the one bringing up something else.
Okay.
Or at least I thought he was.
Yeah, there's potential of that, but just looking at what I was interested in is the solar eclipses, man, where there's this object that moves in front of the sun and blocks the sun. I mean, but you can't see exactly what's blocking the sun. All you see is a totally black, flat thing that's blocking the sun, man.
No, you can see it. You can actually see the surface of the moon that's in front of the sun.
No, I mean,
clearly. You want to see a picture of it?
I've seen two eclipses like this, and neither one, man, that I photographed myself and videotaped and did everything I could. Did everything I could to fucking see that goddamn moon.
Yeah, but you didn't have the credit.
Fuck all, man.
You gotta put it in Photoshop. You gotta put it in Photoshop.
Like just put it in Photoshop.
You gotta layer some shit, add
layer
some shit
on there.
Fuck all, man. Ain't shit. Fuck all, man.
Pull in a couple cut and paste, little cut and paste.
Glasses on. I got filters. Fuck off, man. There's nothing, man. There's no distinctive fuck all of the moon,
there, baby.
When you're done with all that, it's like voila, there's the moon for you during an eclipse. Hey.
Voila, I got some Photoshop. Yeah, fuck off, man.
Let me show you a picture that might make you cry to your mommy about that.
Jimmy Jedi would tell you to fuck off, man.
Jimmy Jedi, I'll take Jimmy Jedi.
Yeah,
and his lunch.
Well,
his lunch money.
Rest in peace, man. Rest in peace, Jimmy Jedi. But Zanuck, Kosho, you guys went around with Jimmy Jedi back in the day. I remember.
Jimmy Jedi. Where's my moon? Let me show you a moon.
Anyway, he'd tell you to fuck off.
If you have the right type of photographic equipment,
if you got you gotta have the right type of equipment. You gotta have the right.
Well, you got to it doesn't take a genius to figure out. You're looking at the sun and only part. It's not completely.
Hey man, I'm not. Dude, Zanuck, I'm not against you, man. I mean, it does line up, man. I give you that.
It has a big ring around the outside. It's not. It doesn't take up all of the sun. So you.
But you and I are not going to
pretty bright
photograph. You and I are not going to photograph the moon's surface during an eclipse.
Yeah, you get it dark enough. Yeah, you stack up like 20.
You and I aren't going to do it.
I'm talking here, tough guy.
Fuck off,
Zanuck. Come on. Oh, come on. Hey, so you put like 20 sunglasses in front of your telescope, you might be able to see the surface of the moon, the craters.
I get where you're going with it, man. I have seen photographs that say that we can see the moon right in front of the eclipse, and they were like, okay, well, why
How
not?
they talk baby talk too when they talk.
The thing that they claim they call it they try to call it Earth shine. So they try to claim that there's certain footage where when that dark thing, whatever you want to call it, that black circle is either absorbing or blocking, whatever it's doing, they try to claim that with their special equipment, there's only like a few of these. They definitely look like layered jobs. But anyways, they try to claim that there's Earthshine, meaning that right when the eclipse is exact, that there's still light that's getting around the moon, coming to the Earth, even during the eclipse while it's happening when it's darkened on the Earth, somehow reflecting off of the little rocks and stones and things on the Earth, and then shooting back to 250,000 miles to show this nice little reflection of the surface of the
you can see Tycho's crater. Yeah, fuck off. You can't see Tycho's crater. Fuck off.
But people have done like very highly detailed, like the highest zoom and also like with the electromagnetic spectrum, whatever that dark thing is, it is just like it has no magnetic field. Like there's a magnetic field surrounding it, which is why you get those kind of toroidal, all of that. But that actual dark thing, whatever that is, it's like it's just like the void. I mean, whatever it is, it does not have any features to it, let alone what some of these guys try to claim when they do whatever computer job they're doing to try to add that in there.
Yeah,
but
man.
I've never seen anyone like legitimately actually replicate that on an amateur level. It's a lot of these guys that found something online and they're just repeating it. And there's
I'm like, I wouldn't say I'm, pretty good at Photoshop, but I'm damn good. I can, dig some levels and get all kinds of different. All the photographs that I took of the solar eclipse, man, I couldn't recognize the moon, anything, nothing, zero, zip, nada, nothing. But yet they got some kind of special lenses, and well, of course we can see the craters on the moon because during the eclipse because my special lens. I got a special lens. Yeah, fuck off.
It's a filter.
So, I got a question for you. If it's not the moon, then what is it?
I don't
Because
know,
just
man.
saying it's something other than the moon does no value. I mean,
I'm not saying it's not the moon. I'm not saying it's not the moon. I'm just saying that you can't fucking see any of the known geographical formations of the moon during the eclipse, man. All you see is a black circle, man. That's all you see.
Well, what I can say is that we have a model, three-body system.
Three-body problem? Yeah, the three-body problem, man. Want to go into that?
Hold on. A three-body system, the Earth,
Three-body
Moon, and
problem.
the Sun. Hold on.
Yeah.
And it accurately predicts these eclipses and what we could expect to see with them. And
It's
that
a
assumes the
post-diction.
moon.
It's not a prediction. It's a post-diction. Anyway, that's
and
another.
it's called the three-body problem because it's a problem for them that's not resolvable.
That's right, Gio. Love you, brother.
I'm not going to get into that because that's a whole other thing that you're honestly getting wrong. But specifically to solar eclipses, we can predict them. We can say what's going to happen before they happen.
Yeah, you're not familiar with the sidereal cycle?
Yes, I am.
Okay, well then you know, man. It's been documented for a very long time that they can about every 18 years or so, man. They can predict exactly what's coming. That's all.
They can predict within a certain period of time.
Yeah,
hold on.
It's like 18 years, man. That's it. It's
Hold
not
on.
like fucking thousands of years. Can you predict 1,000? Well, yeah, every 18 years it does this. That's it. That's all they're saying, man. That's all it's been predicted, man. It's post-diction. It's not even prediction.
If you don't let me speak, I can't really say anything.
I'm not going to let you speak, man. Sorry, man. I don't have a lot of time, but carry on. Go ahead.
Okay. The sorrow cycle can predict when an eclipse is going to occur. It doesn't predict the path of totality. To predict the path of totality, we use Newtonian physics.
Great, man. Grab your fucking whiteboard, man. lay it out for us, man. That'd be great.
Sure. Give me a second and I
Yeah,
will.
this is like, I'm not trying to call you an AI bot, but this is exactly what the AI would say.
Exactly.
These are just like the top 10 like Googleable things that
Yeah.
they try to claim. It's like,
hold on, let me get my whiteboard. Hold on.
There you
I
go.
got a whiteboard. I can totally, without a doubt, I can do it.
it's like they've already, they
can you
give
see the
us
chat?
these maps that are already concocted to claim what they claim they are, and then they fit those to certain models about what they're claiming the eclipse is doing. And then
Can you see the
trying to,
chat?
All
it's
you
always
have
like
to
the
do.
backup where they try to say,
I'm
oh, but
looking in the chat. I don't see anything. What do we
You
got?
don't see it? You don't see it there. I just posted
So
it.
all you have to do
Hold on a
is
second, I got a picture
provide
for
an
you.
alternative model that makes similar predictions and has
Yeah,
the same
fuck off.
explanations.
All I gotta do is go out and go
Here, I got a
surfing,
picture
man.
for you. All right, got it in
Fuck
there.
this.
You see it?
Well, I'm not seeing shit, man. Am I
There
on
you
the
go.
wrong? Am I
There
in the
you go.
wrong fucking?
Ooh,
Look
that's
at
pretty. Did
Am I
you
in
take
the?
that one?
now that I didn't take it. This is a.
Oh,
What are you guys
bummer.
in? Live stream voice?
You could probably see this if you had like 20 sunglasses and put it in front of your telescope. You probably could get this kind of shot. It's just a lot of filtration, with just a little bit of the hint of Earthshine on the back of the. I mean, those geographic.
Hey, are you
Sure.
guys in live stream 1 VC? What are you guys in?
Live stream.
yeah,
text,
the text.
gang. 2 up.
Text. Got it. Okay. Now I can track with you guys. Okay, here we go.
Yeah, there is that other channel that's like linked to the VC.
Yeah. It's in the VC. Yeah. But anyway.
This is like the main one. Right?
Oh my God, there's a lot of math and drawing lines and things. It's amazing. Oh my God. Hey, if I went outside, man, and said, hey, man, the Earth to me feels like it's not moving. It's not shooting it through space at fucking all millions of miles an hour or whatever. But yet somehow the Earth is lying to me, man. I mean, it's lying to me. The fucking Earth is lying to me, man.
Couldn't you be just not sensitive enough?
I'm not sensitive enough, you know. I gotta get some more estrogen in my life.
You're just not sensitive. You're just not sensitive enough. You're not touching your feelings.
I'm not sensitive. I don't feel. I need some more estrogen, man. That's what I need, man.
There's things we can't feel, and all the things we know that are happening here based on our measurements. You wouldn't be able to. There's no reason.
I can't feel shit. I can't see shit.
You're right. You can't.
I can't fucking fuck all shit.
Literally, there's nothing to feel.
There's nothing to feel. There's nothing to see.
You're
There's
right.
nothing to. Yeah. There's no spin. I don't know rotation.
No this, no that.
Changing velocities. Oh my God. I mean, it would change in velocity. I mean, I would never feel a change in velocity. Fuck. You know, I'm a fucking idiot. Of course I am. Yeah.
I mean, Zanuck, you probably don't meditate, but Zanuck, if you were gonna do some meditation, you're in the most calm, still. Dude, the concept that you're actually whipping and warping faster than a speeding bullet. Like,
exactly.
Yeah. I'm with you. I'm tracking.
You got to do a little yoga, maybe some meditation. Yeah.
We're talking about something that's just not. We're talking about a feeling that's not feelable.
Well, it's a feeling that's not feelable. Did you just say that?
Yes, on purpose. On purpose. I thought about it before he said it too. By the way.
That is this. Come on, bro, man. I mean, come on, man.
It's an unfeelable.
It's a feeling I can't feel.
Unfeelable feeling.
Of course it is. It's a feeling I can't feel, man. I mean,
it's not feelable. I.e.,
that's super fucking genius, bro. That's super fucking
genius. It is genius.
It's next level genius,
really
man. It's out of this world genius,
creativity.
It's crazy.
Yeah, that's profound.
Of that particular statement. It's
that's profound. I'm calling my wife and telling her right now.
Dude.
Please do.
We gotta fucking
Enlighten your friends.
We gotta carve this bitch in stone, man. That is some serious.
Danik, if you went a consistent speed in your oval track in a stock car and didn't feel any acceleration or braking because you had the right gear and the right speed, what about the outward push? In other words, the outward push towards the outside of the track, you would feel. Regardless,
gravity just cancels it all out. Gravity.
Let me respond to that
all out.
because I've been at my favorite. I'm very sad. I have a tear in my eye because they just removed Auto Club Speedway from the circuit that I used to participate in. So and I love going around a turn at 155 miles an hour. That it's basically like making a U-turn at an intersection going 150 miles an hour. It's freaking crazy. But anyway,
so
your
again,
point is
it's
well
not
taken.
about
However,
acceleration.
Can I finish?
Not about
Can I finish?
acceleration,
Can I finish?
right?
Hey, can I finish, Dan?
No, but
Dan,
let's make
please.
sure we're together
Please,
on this.
I got. Let me
It's
finish.
not about the
Hey,
acceleration.
Dan, you're being rude again.
Oh,
You do this all
I'm
the
just
time.
making
Of
sure
course
we're
I'm
in the
being
right
rude, man.
conversation.
We're
Let me
all
finish.
friends.
Let me finish.
Fuck,
Let
we're
me finish.
friends, dude, man. We're not
I know.
enemies.
Let me
We're friends.
finish real quick because I was in
Treat
the
us
middle of
like
a thought there.
friends, man.
So yes, while you are
Guys,
correct that
everyone
the
relax.
speed is, you are correct that the speed is constant. However, there is something called a velocity change, which doesn't involve the speed. It only involves a change in direction, and that constant change in direction is an acceleration. So that also is calculable and feelable, and it's unfeelable when it is the levels that we talk about with respect to the Earth hurling through space at millions of miles an hour and making slight changes in direction, but they're so slight we can't feel that either.
Okay, if I had a perfectly circled track, then do you think you'd stop feeling the outward centrifugal force?
Of course, you wouldn't feel it if you have a perfectly circled thing, or even not as perfectly
Fuck
circled.
off.
You
No,
wouldn't
fuck off.
feel it because it's such a small change in direction. That
Manic,
value,
come
that
on, man.
magnitude, the magnitude of the direction change is what we're talking about.
You would
If that
fucking
magnitude,
feel it all
God
day
damn
long.
it, Data, dude,
Fuck.
dude,
Xanax. Fuck you, man.
come at me, bro. Come at me,
Zanuck,
bro.
are you trying to say
Fucking
that
Jimmy
you
Jedi would fucking
Come at me, bro.
I know, Zanuck, you're basically saying that if you were on one of those Gravitron, those rides where you're stuck up against the side, that if you just kept going like that, eventually you would just be having a cup of tea. You would just
That's what he's saying. That's exactly what he's saying.
I'm not saying that at all, actually. I'm saying
cup of
if the
tea, man,
gravitron,
and a cigarette. I'm gonna have a
add a
cigarette.
couple million years to it, and you're
If-
just chilling.
if
That's
a,
it.
grav- if a gravitron was going 1 millimeter per year
Shit.
in velocity, i.e.,
Even
its
Xanax
speed
laughing. Come on, you're
and
laughing,
change
Xanax.
in
Just laugh.
Okay.
Just fucking laugh for fucking one time, man.
I'm always,
Come on, man.
dude, you should see my face when I'm glowing
It's
like a
pretty
freaking
funny,
light bulb
dude.
right
Come
now.
on.
I'm always
I mean,
laughing here.
I know
I'm
you
laughing
are,
right
man.
now.
I love you, brother, man. I do. I get no ill feelings for you, brother. None.
As you
Love
should.
you.
As you
You know,
should.
so. Yeah, but you make me laugh, dude. I gotta give you that.
That's why I'm here.
Wait a minute. So you're saying because it took you longer, no, it doesn't make sense. Because it took you a year, you didn't
Yeah.
feel it?
Yes, exactly.
But the
Because
speed is
change
still
the
there.
magnitude,
So
magnitude of the
back to
direction
Gio, it's
change.
back to what Gio said. Because the
No,
speed
you
is
have
still there. So just having
you-
it be longer doesn't do shit for you.
Yeah, because that's the
You know how they say-
acceleration.
hold on, Zanuck, let me say this, and then you can go. You know how they say Coriolis that gets lost in the winds? Well, this one gets lost in time.
Yeah, that's not a bad
Not
comparison.
bad, Gio. I like that.
Let me respond to Waterman real quick. Yes, if you were in the centrifuge and you were spinning at one revolution every second, whatever they do, you would feel it. Now, if one revolution every year, you wouldn't feel it. There's your answer. It's an analogy for you.
It's a good analogy, man. I'll give you that,
But
man.
the speed is still there, so the outward force is still there, regardless of how much time you spend.
No,
Stop
if
it.
you have the speed, and there is no change of direction, then you wouldn't feel anything.
I don't
There
feel
is a
shit,
change of
man.
direction.
It's got to be a change. Dan, I can't pound this in your head hard enough. You have to have a change in velocity. Velocity means magnitude of the speed or magnitude of the change of direction.
We talked about this with the track.
Both have to be present, otherwise there is no force.
The velocity was your 155, right? That's your track speed, your average speed, right? So that's your velocity. The
No,
outward
that's my
force,
speed. It's not my velocity. Velocity is made up of two components. We have a velocity which is speed, and we have a velocity which is magnitude, and a velocity of direction. And direction has magnitude as well.
Well, you're talking again about the feeling you can't feel that we know is there as you go
Unfeelable.
around something.
Yeah, but
You can say, now, if I took a year to go around that track at 155, you're saying I won't feel it as much. And that's not true because it's a bigger track.
You're
The
talking. You're double
155
speaking.
still exists. The
You can't
radius
go
still
155.
exists. Everything still exists.
Dan, what is wrong with you, man? Come on.
Hey,
you can't go
nothing
155
wrong
around
with
the
it.
track. You just can't help yourself, can you?
Come on, man.
It's impossible.
Xanax, don't give us that fucking smiley shit.
Yeah,
I'm
you're saying
giving him smiley shit right now.
if I just drove longer, I won't feel it. Isn't an answer.
Okay, you're
It's not an
confusing,
answer.
conflating, and
Exactly.
what's
It's
other
not an answer.
adjectives? Because I can't even think of them. No,
Yeah,
Dan,
because the
absolutely not.
linear
No,
time
Dan,
didn't
Dan,
negate
Dan.
the speed. It didn't
Come on, you can
negate
do
the
better than that,
angle.
Santa. Come on.
It didn't negate anything.
You can't go around. You can't go around the track at 155 and not go around
Get
the
in
track.
that ball, man.
I mean, it's so
That's
stupid.
just-
I can't believe we're even talking about this, Dan. It's such a silly statement.
All right, I tried to
You
equate
didn't.
it.
You didn't try very hard. You have to really go
No,
stop,
I did.
be quiet,
I really
write
did.
it on a piece of paper, draw it on a piece of paper, and see if you're making any sense. You're not making any sense.
Hey,
You cannot go
I
around
just want
track
to.
155 and not make a turn. It
If you
makes
did
no
a
sense.
600-mile race instead of 500, are you going to feel it
Yeah,
less?
but if it's not turning, if you're not turning, yes. If you're going 155 miles an hour, but this
Turning,
track is so big that you only go around it once
Fuck
every
off.
year.
but you're
You'll
still
feel it.
God damn it,
turning.
come at me, bro.
But you're still turning.
Yes, you're still turning, but you wouldn't feel it because the turn is so slight.
It's not any more slight. It's just bigger.
You would feel it, man.
That's
It's
what
not
bigger
any more
means.
slight.
That's what a bigger circle means. The radius is larger means the turning
No,
is less. Dan,
no,
Wait a
I'm
minute.
stopping.
that's not
Santa,
what a
I
bigger
Santa,
circle means.
have to get
Santa,
going.
listen,
Dude,
Santa,
I gotta
listen.
go, man. I got an appointment. I gotta roll. So I hate to. You guys are a lot
Fuck,
of fun,
man. Listen,
dude.
Santa.
I'll listen to the recording later. Have fun. I gotta go. I'm sorry, bye.
You Mongo.
See you guys.
Fucking Mongo. I love you, brother.
See you.
All
I
right.
love you.
Be good. So yeah, man, if you're on a 150-mile turn, yeah, you'll feel it. You will feel it if you're going, 80 or 100 or 17,500 miles an hour.
All right, let's see if
Well,
he's right. If I got a half-mile track, I'll never stay on the track at 155 because the outward push.
right. Yeah,
If I'm on a 3-mile one, he's
3
right.
miles.
There's going to be less outward,
Right.
but I don't think.
But it would still be a significant outward, man, for sure. Even at
He's
3
trying to
miles.
say it'll never be significant, but I don't see why.
At 100, and
It
he was
doesn't have
going.
to be significant. It has to be change. It has to be a change in direction, not significant. So the consistent is the rotation, but we're being warped around that. It can't. I don't feel it's going to be consistent the other way. The orbit. I know that we were wrong about one thing. We used to talk about, let's say, the moon going around the Earth, and it used to have to speed up to go around it, then slow down to stay with it, and speed up to go around it. That's wrong. We used to say that a lot.
I remember that.
Yeah,
I do. I remember that.
that seemed to make sense at first, but it doesn't.
Yeah,
Because
I even when we were in Hollywood, man, I had a couple people ask me that. I'm like, I don't know, man. I really don't know. I mean, if it was orbiting above our head and speeding up and slowing down.
So I don't think we need to speed up and slow down to get around the sun. Remember, we're not really going around it; we're chasing it.
Right, we're chasing the sun, shooting in a corkscrew around the sun. Right?
People claim to have known that. I'm like, why didn't they show us that in school? People go, I seen
Yeah.
that in school. I'm
Nobody's
like,
ever shown that shit in
I
school.
know, I know.
Well, they can't show you that. I mean, that was what was so epic about that video is like, oh shit, man. Wait a minute. What do you mean we're shooting around and shooting through space at 1.5? What the fuck? Million miles an hour? Yeah. That's when it became crazy for me, man. I was like, no, that doesn't make any sense, man.
That's
Wait
when
a
they
minute.
just kick in. But then the sky looks like this, and they're like, well, it's just so big.
It's
like,
so,
not
so
another
big.
so big
So
answer.
big. It's so big. And you guys, you just can't feel it. If it's a 250,000 million mile fucking radius, you can't feel it. Yeah. Zanuck, I know you're biting your teeth, man. I know you are, but bite your teeth, man. Bite your teeth.
Okay, so if I'm going 155 miles an hour and it's only a soft turn,
we're talking 150-mile radius circle, basically. 150-mile radius circle. Could you feel?
Okay, so here's the point. If I'm spinning
left,
every
can you
day,
feel yourself turning left?
if I'm spinning every day, at some point I'm going with the orbit, and at some points I am twisting against it. There should be a.
That's true. That's true, man.
Let's see, maybe that doesn't constitute a speed difference, but you're definitely.
Well, for 6 months a year, man, we go around the sun according to education system, and for 6 months we're around the other part of the sun, man. I mean, that's what we were taught, right? Correct me if I'm wrong, man. I mean, that's what we were taught.
Should be a different sky for sure.
Shouldn't we see a different nighttime sky? Polaris and everything should be fucking completely fucking whacked every 6 months, but it's not. It's not how it works. And I always thought that was an interesting point, man. It's like, wait a minute, man. If we went around the other side of the sun, shouldn't we see like a totally different sky? I mean, come on, man. I mean, that only makes logical sense. Geo would agree with that 100%. But it would just make total sense that we would see a different sky every 6 months. I mean, come on. And we don't. Yeah, that's weird. It's weird shit, people. It's fucking weird, man. Come on. Somebody make it more weird than that. That would be great.
You want to get weird? You know what Obler's or Obler's paradox is?
No, man. Fill me in, huh?
Well, in their model, like you can just point into a direction. There's going to be a star there, or there's going to be a galaxy there. There's going to be a light source in that direction. If you were to point in that direction. So why does the sky even get dark? Because there's photons coming in from every single angle, everywhere you could possibly point.
Yeah, exactly. I'm texting somebody right now, man. Hang on a second. I'm still with you guys. I am. So, just
Dan, what's your point though, Dan? If you get your, I don't know if your argument should be with Earth or maybe it should be with like the ISS, because in the ISS they're going around Earth every 90 minutes, and now you got your track. Now you got your track that's not taking a year; it's taking 90 minutes. Dan, you there?
Yeah.
You got your track; it's taking 90 minutes. Why is there no outward force on the people? Like shit should be going towards the outer part of their orbit. You know what I'm saying? Like if the cupola was on like the outside of like the part that's away from Earth, that should be where everything's like going to that part because of the centrifugal force.
Yeah, there should even be artificial gravity if they did it right and they stood on that edge.
Well, I'm just saying your argument makes sense for something like the ISS or something.
True.
I'll break them off with that next time.
Man, I don't always have the energy. Like I got hassled to come and do McToon yesterday, and I'm just like,
yeah, fuck those Mongos, man. Right?
You gotta be in the mood. You gotta
be in the Dan's keeping them. Dan's keeping them alive over there.
Fuck those guys, man.
Dan's keeping them alive.
Don't do it. Don't do it, Dan. It's not worth it, man. Don't do it.
No, that was at Gems. You say I'm over at MMM all the time, and I'm at Gems all the time.
Dude,
You're
I'm
keeping them
offline.
guys alive too.
I'm offline most of the time, man. I'm just talking about other crazy shit that's going on, but no, I love. Thanks, Gio, for everything. Putting on the live stream, doing all that shit every day, man. Clicking all that shit, bro. Thank you. Great place to hang out. Yeah, and talk
All right,
about what.
Kenny. Did you get thrown out of somewhere?
No, man, dude, man. I came here.
Tell the
on my-
truth.
No, I came here on my own. No, I'm not kicked out of anywhere, dude.
Come on.
Although YouTube is totally, what do you call it, shadow banning my ass, but that's cool. What are you gonna do, man? I mean, even you don't get notifications when I go live, man. Not even you, bro. That's how shadow banned I am, bro. I mean, if Dan the Waterman don't get a fucking notification that I'm live, there's a problem.
I get notifications of you being live.
But you never come in the chat or nothing.
Oh my god, you had all the jerk offs there 3 weeks ago. All the biggest jerk offs there were.
It doesn't matter, man. You still come in the chat. You got a wrench. It's not like you're gonna get muted or something. Fine. You know,
Whatever. I don't think those are quality people.
who knows, man? I mean, you're talking about Hitch and Jaybird. What are you talking about?
Jaybird
Jaybird?
don't. He don't mean me no harm.
Exactly.
Everyone else does.
GM. Yeah.
Oh
fuck
yeah,
that.
there's a quality guy. But
Yeah,
how
he's
long
gonna-
do you want me to talk about him?
I don't know, man. Jim's kind of like a whisper in the wind at this point, man. I mean,
So is everyone. That's the problem.
No, okay. What do you mean by that? So is who is everyone, man? Who's everyone that's not participating in the
I can
conversation?
name more people that.
I want you to name
I'm
all
gonna
the
bust
people.
out my
Listen,
phone book. I'm just going to talk about people locally, right? I'm going to go through my
local.
phone book.
Okay,
People that we don't talk to anymore and don't see. First one is Lindsay's boyfriend, or the father of Lindsay's kid, that got hassled up at when he got arrested. Remember, he got arrested. Andrew got arrested at the Griffith Park Observatory. We haven't seen him in 5 years, right? Remember that guy? All right, I'm just gonna go flip through my phone, right? Okay,
Yeah.
so people we can't flatter. Okay, that dude Adam that we met in OC never talked to us again. Alex we could call, so there's one. Okay, so there's one real
Alex. We're talking
Yeah.
Alex. What was his YouTube name? He had a YouTube name, man. It was called Ace Flat Earth or something like that, right?
Ace Pro.
Ace Pro. Was it Ace Pro or Ace Flat Earth?
I don't
Dude,
know.
this is like
but
5,
he's
6
legit.
years ago, man. It's at least 6 years ago, man.
All right,
I
so
met-
that's
I met
one guy.
Ace. I call him Ace, man. He's just
Right,
my
exactly.
Ace.
Okay, so look, Angel, he's gone, right? We never see Angel anymore.
Oh, fucking Angel's gone for sure,
And-
man. I mean,
Okay, Angela's around, so that counts as one.
she's still around.
Right. Okay. Let's
Right.
see.
You're still in the A.
Attilio gone.
I
right?
have his email.
Bling
I have
bling.
his
Wait, listen. Bling bling gone. Right?
gone.
I'm
Bling
just
Bling's
doing,
gone.
I'm just doing my phone book here.
I love
right?
it. I love Bling Bling's
I mean,
gone.
I'm just going through my
She's
phone. Right?
gone.
Caroline's gone.
Gone.
Who's next on this list? Pontius roughly disappeared. I'm up to
Pontius?
C.
No. You're talking the not the flat earth maker guy. Clock.
Yeah.
Flat Earth. Pontius is gone?
Well, not exactly, but I mean, he's not participating in anybody's anything.
Okay. Gotcha. Okay, I go with that.
And Patricia, of course, same thing. D Marble.
So you hold on. Speaking of Patricia, man, I was in. I just happened to click on Karen B's Coffee Talk on Monday, and I kind of came in, rewound it. You know, I couldn't tell you exactly where it was, but I just happened to catch some people in the live text, and one of them was Patricia Steers and Mark Sargent. Both were in Karen B's chat on YouTube. And I thought that was interesting. Even I said hi to Patricia.
What makes you think it was her? Because Mark doesn't hang out in any chat, so they were both.
I know.
They were both probably
That's what
sock
made it
accounts.
weird. That's what made it weird, Dan.
They were both probably sock accounts.
It's kind of weird.
Both of them probably sock accounts. Anyway, you want me to go through the rest of the flat earthers that are gone out of my that we don't see? I mean, there's lots. That's just the people we know that are gone. It's too bad. It's awful. It's awful. So anyway, with all these new people that are going to come around, I hope they're not just like, yeah, TikTok, flat earth, TikTok, flat earth. I mean, I hope they got some intent more than just to think flat earth is cool. I hope they care about the world or something, truth or something, anything. I hope they have something in them. Real bad. Kenny, is this CJ guy that's been around on Discord the same CJ that we know in person? Alrighty then.
Flat Earth dude, man, you got to unblock me on 24/7. It's been years and years and years.